Start a recording for this in just a minute.
It's recording now.
It's recording now. Okay, great. So I guess we're good to go then. We collapse this and switch over. Okie doke. Well, thank you very much for joining us. I'm really excited about the workshop for today and all the presentations. Been looking forward to it for a long time. So today we'll talk about tools for building BioCompute objects on DNAnexus, 7bridges, and Galaxy for deposit into an access-controlled database. A brief introduction. So before we get to the other sections, this will be broken into different sections. So each platform will get a chance to kind of talk about the work that they did and the way that the working with BCOs works on their platform. Before we do all that, I'll do a brief introduction to BioCompute. I'll talk about some previous work that we've done, including some other workshops and things like that, some updates since those workshops, and then I'll introduce today's workshop and say a little bit about the BioComputeDB, the kind of centralized repository, and then I'll introduce the other speakers. So if you have any questions or comments, we've enabled the chat to the presenters and organizers, so please feel free to put those in any time. We'll sort of leave it up to the presenter in terms of when they want to address those questions. They may leave it for the end of their section. We also have a 15-minute Q&A built into the very end of it, so depending on how big the question is, they may decide to just answer it right then and there, or if it's big and it kind of warrants maybe a deeper discussion, they may decide to hold it till the end. We'll kind of leave it up to the presenters in terms of how they'd like to handle that. Okay, so just to introduce BioCompute and the idea of BioCompute, this all started from a need for some clear guidelines because there really was not any standards or guidelines for things like documentation and reporting of workflows. And this is separate from things like workflow languages. So the portability component is already pretty well represented in things like CWL and WDL and Nextflow and lots of other workflow languages. There was a need for something in the descriptive space to provide clarity around what's actually being done and help someone to understand what's being done more completely, more thoroughly, and also a better understanding in case, for example, if they want to repeat it, kind of understanding which parameters to change and things like that. So there's a lot of metadata that's not really captured in workflow languages for human understanding. And so that's where BioCompute comes in. So the goal was to come up with guidelines for exactly that. So what kind of data needs to be present in order to meet this standard? So you're not just providing sort of plug and play functionality with a workflow language, you're actually trying to help someone understand it, whether it's someone else in the lab or the next person to come after you one day, or a journal editor or some sort of regulatory reviewer, or even just yourself, in the future. And then number two, how is that data represented? So if it's represented in a very structured way, then we can work with that data programmatically, and it has a little bit more predictability to it. So it's no longer just sort of the Wild West where anyone just submits whatever they think that they should in order for it to be understood, and that's rarely enough. And if it is enough, is kind of difficult to find when you need it. So this provides clear structure and format for this kind of reporting. And so kind of fast forward through a lot of work, excuse me, including dozens of working groups, 3 workshops, multiple draft specifications and schemas, and lots of, smaller interactions that were not officially recorded. We finally arrived at a standard, and it was officially standardized through IEEE in 2020. So the official name for the standard is IEEE 2791-2020. We still refer to it with its colloquial name, which is BioCompute. And I will continue to refer to it in that way. This is sort of similar to Wi-Fi. I think the official name is IEEE 802.11. And of course, nobody calls it that because that's also a mouthful, so everyone just calls it Wi-Fi. So a similar thing here. I'll continue to call it BioCompute. I think the rest of the presenters will as well. But a lot of work went into this. In total, well over 400 people contributed in one way or another to building the final schema. So once we had a schema in place that represented what we felt was a thorough accounting for description of workflows, and it was finally standardized, eventually the FDA adopted it. The Data Standards Catalog adopted it. So this was the first framework to be adopted. It's now accepted at 3 centers, CBER, CDER, and CIFSAN for most drug applications. And so the way that the BCO works, it's broken down into top-level domains. So there's 8 top-level domains plus the metadata, and 5 of those domains are required, 3 are optional. So these are all sort of conceptually related information. So the provenance domain is for user attribution and the role in the work. So who contributed to the work, what did they do? There's specific language around that, and well-defined language. So depending on exactly what the role was, that's captured there. The execution domain is anything needed in the execution environment to run the analysis. So was it run on Hive or Galaxy or 7 Bridges or DNAnexus, or just run at the command line? What were the environmental variables? What are some of the software prerequisites, and so forth? The description domain is used for describing each of the steps in the pipeline, and it also includes an IO for each step in the pipeline, which is distinct from the global input-output for the entire pipeline, which I'll talk about in just a minute. So you have some more traceability at each step. It's also got a place where you can put some keywords in to describe the workflow. The parametric domain is a place to record all of the parameters. So each parameter is associated with a particular step. Usability domain is a free text description. So this is where you would provide some commentary and some context. You know, what was the purpose of this pipeline? What was it trying to do? Any other relevant information that the reviewer should know about, or recipient should know about, author comments and things like that. So even more metadata, for example. The IO domain is for global in and out. So this is what's needed to run the pipeline and what the pipeline produces as sort of the product at the end. And so there can be a little bit of overlap with some of the description domain input outputs in the individual steps, but it can be a little bit different. So for example, if you've got a 4-step pipeline here that has step 1 is QC, step 2 is alignment, step 3 is variant call, and then step 4 is filtering, you may have QC takes file.fastq as an input and produces some fastp file as its output. And you're not actually going to work with that fastp downstream, but you do want to include it in your final report because you want to demonstrate that you're working with high quality data. So even though that's created in the first step, it still goes into the global input and output. And similarly, if you create maybe a stat file at the step 2 alignment, and you're not going to work with that downstream, and you don't plan on including that in your final report, that's still part of the description domain. So that's not part of your global input and output. So all that to say that the global input and output is not just as simple as all the inputs needed in the first step and all the outputs needed in the last step, although that may be true in many pipelines. So for probably 90% of the cases, the IO domain is going to satisfy what most people want to know. What was the input for this pipeline? What was the data transformation? And what was the output? But you do have that individual traceability, which comes in handy, as I'll mention later, in the description domain. So the error domain is just like it sounds. This is for recording inherent error in the pipeline. It takes 2 different forms. There's empirical, so if you can test it with in silico data, for example, it would be empirical, and then algorithmic would be for fuzzier things like random number generators or machine learning and things like that. Extension domain is user-defined domain, so this is any way of extending it beyond the base schema. The only thing that's required is some sort of schema, the user-provided schema, so that you can actually validate it. And as long as it has the schema and the extension domain that validates according to that schema, then it's still a valid BCO object. So this is a way of extending it beyond the base BioCompute object if for some reason you feel you need to. And then there's the 3 metadata fields. These are not a domain proper. So the object ID is a unique ID associated with the domain. The specification version is used for validating the object, and then an E tag is another way of identifying it. So this is an intentionally opaque field, so it could be, for example, an SHA-256, where you don't disclose what the hash was, and only the recipient knows, for example. So those are the basics with a BCO. And so previously what the kind of work that's been done included a BCO exporter on Hive. So this was the initial implementation of it. One of the main goals for all of this is to try and reduce the administrative burden. And so some of the focus lately has been on creating some tools and systems that will kind of help with that goal in terms of reducing the administrative burden. And so there's an exporter on Hive, which was meant to kind of pull all of that data automatically and help you build a BCO. And this was the first implementation of it. There's also a form-based editor for making BCOs at BioComputeObject.org, which I'll show in a minute. This one takes a little bit more effort because you have to actually go through and fill out the form and provide the information. So it's not as automated as some of the ones that you'll hear about today, but it's still an option in case you're not using a platform, so that you can build one. It kind of walks you through the steps, tells you which fields are required and which are not, and then validates the object for you, and also has a direct connection to an access control database, so you can submit those. We also had some joint projects with things like Common Workflow Language, CWL, and also Research Objects, which is RO. So that's a project that aims to package all of the scientific assets, all of the digital scientific assets in a project in a very particular way. And so for that project, that was used with Nextflow. And Stian Soyland-Reyes from Manchester put together a really fantastic tutorial to walk through how to build this workflow and then how to record it as a BCO. There was also a paper that was published from the perspective of a reviewer on using BCOs. That was King and colleagues. And there's another one currently in the works from a sponsor's perspective. So that one's forthcoming, so be on the lookout for that one. So some updates since then. One of the things the community's been working on is an importable package. And so this is a Python library, and you can import it directly into Python at the moment. In the future, hopefully there will be other options for things like JavaScript. But at the moment, the implementation is in Python. And so this lets you programmatically work with BCOs to do some extra things that are maybe not possible in the editor or in other platforms and things like that, maybe some smaller things that you need to do. And so the way it works is it creates a Python class object from a BCO. So you'll import the BCO, and then you import this library, the BCO library, and then it's got a lot of tools for working with the objects. And so this was built according to a big UML that mapped out the relationship of all the different pieces in a BCO and all their relationships to each other. And so some of the ways that you might use this library might be to retrieve publications from a specific date range from all of the authors in the provenance domain. Or if you wanted to sort your studies by the number of samples. There's a lot of cool things that we can do with BCOs now that we're starting to record data in this way, and we've got a predictable structure to it, and we know what the data types are, and we know what to expect. You can check your own environment for compatibility with a particular workflow. So you load up a BCO and just run that command, and it'll let you know if your environment is ready. There's a workflow validator, which essentially just checks to see if the file types line up correctly. So that's not part of the IEEE validation. So this is kind of another level of validation. So you want to make sure that even though it's saying it's got an output file for step 1 and an input file for step 2, if step 2 needs a BAM file, for example, as an input, then you could check to make sure that you're getting a BAM file that's coming from step 1 and going to step 2 instead of maybe a VCF file or something like that. So it's another level of validation for a pipeline. And then finally, you can compare two workflows. And so this is the one that I'm most excited about, probably because we've had a few folks ask for something like this. And so the command line version of this is already implemented, and we're working on the GUI version of it right now. And so this is the mockup that we're working from. And the way that it works, you load up two BCOs, and it will make its best attempt at lining up the individual steps of these workflows based on tool category. So you can see in this example, BCO1 the first step is an alignment using a tool called hexagon. And then in BCO2, it's an alignment using BLAST. So it'll align these two because the tool category is the same, and then highlight the tool in red because the tool itself is different. And then in step 2, it's variant calling, and the tool is heptagon in both cases, but the version is different, so that gets highlighted in red. And then the parameters are listed underneath, again, with the differences in red. BCO2 then has a step 3 for filtering, which BCO1 does not have, so that's sort of like a gap. And then annotation is present in both with the same tools, but with a different database. And then there's an enrichment step in BCO1. And so then it'll create a minimum overlap for both of those off on the right. So you get an alignment, variant calling, annotation. So this is a really, really nice way of just kind of getting a 10,000-foot view for a pipeline and understanding what it is that it's doing and what these two are doing from all of this data. It just gives you a really clean, really intuitive look at the pipeline to kind of understand what's going on and how they're similar and what they're attempting to do. And then you've got, the nitty-gritty granular details off here on the left if you want to dig into them a little bit more. And so, as I said, the command line version for this has already been implemented and is working to our satisfaction. This is, you can trick this, you could come up with a very, very complicated pipeline, which does happen pretty commonly, because fundamentally what we're doing here is sort of like another alignment, ironically. But I think that this initial implementation is very strong and I'm very happy with it. And it will probably meet the needs for most comparisons. And, hopefully we'll still receive some input from the community and keep making it stronger as we go. But I'm really happy with it so far. And so the way that this worked, these tool categories up here at the top, each tool is associated with a particular category. The initial implementation of this was done using Daniel Cook's repository in GitHub. But it was pointed out at one of our technical steering committees, there's a much, much better resource for this, which is maintained by Elixir. And so Elixir has a database of well over 26,000 bioinformatics tools, and each tool has an enormous amount of metadata associated with it, including a tool category. So you can see in this example, you search for sequence alignment, it's operation 0292, and anything that has this sequence alignment tool comes up. And that's all maintained in this database called EDAM, which stands for Embrace Data and Methods, because it's part of the Embrace project, which is yet another acronym. It's a big European effort, but they have an ontology and a very controlled vocabulary around the tool categories. So every tool that's in this database of tens of thousands has some sort of tool category associated with it. Unfortunately, Elixir has a really terrific API that's very well documented. So that's what we're using to pull for any of these tools. So as long as these tools are listed in that database, then we can call the tool category and perform this alignment with it. If it's not recorded in that database, then it would not be able to be aligned in this way. And so it would be kind of like this filtering tool here. It would just show up as not aligning with anything else. But most tools, I think, are recorded here, so it'll be a really, really nice feature to have and a really clean way to compare two BCOs and get a really quick look at how similar or different they are. So this is a repository where that library lives. It's BCO tool in the BioCompute Objects organization. Excuse me. So please feel free to go check it out. Just be sure that you're on the dev branch up here at the top left, or just go to this URL here. That'll take you straight there. Okay, so another thing we've been working on is improving the editor. So I mentioned the form-based editor. We've had it up and running for a couple of years now, and we've done a lot of work in terms of gathering feedback from the community in terms of its usability, how much does it help, what are the pain points and things like that. And so based on that, we've redesigned it with a much cleaner look. And so now you only get one domain in your view at a time with these little red asterisks that shows you what's required, and that's it. And so you've got a nice little navigation bar up at the top left here so that you can kind of work your way through one domain at a time, but it keeps you focused just on this piece of it at a time, which is a lot more manageable. And again, the goal is to try and reduce some of the burden. So you can fill in this piece of it and save and go to the next one, and it feels a little bit more manageable that way instead of an infinite scrolling, sort of almost never-ending pile of these fields. So hopefully this will feel a little bit more manageable and a little bit easier to navigate. The current version of this, though, is still available. We're at 22.09 right now. This is on our website, biocomputeobject.org. So we've got a lot of documentation up in the top left, some information about the official standard, IEEE 2791-2020, and then some information about the Technical Steering Committee. There's also some information about some of the tools that we've got underneath. So we are always interested in collecting more feedback. If you think it's helping or not helping, any constructive feedback is very welcome. There's two official ways you can do that. At the bottom, the Contact Us form is just a form where you can send a message that goes straight to our Slack, so we'll get it very quickly. Or you can fill out a bug report or feature request. And that's a link to the repo on GitHub, so you can officially report something or ask for some new feature if you'd like. You can also just send us a good old-fashioned email at object.biocompute@gmail.com. Okay, I'll just spend a couple minutes talking about some projects that have started implementing BioCompute objects. Well, one in particular, and that's ArgosDB. So this is a database of regulatory grade genomes and infectious diseases. So these are using BioCompute, particularly knowledge-based BioCompute objects, to document the entire curation process. And so this is a partnership between Emblema and George Washington University for really the second implementation of FDA Argos. The first one had already existed, so the purpose of this is to expand the database and kind of bulk up on some of the QC processes that are part of the FDA Argos database. So it'll help to identify some genomes of microbial species that are high clinical relevance, particularly regulatory grade sequences, develop more reliable QC, and then prepare the entire thing as an NCBI package. And so this, for example, could potentially be used if you are a physician who maybe suspects some particular disease, but the testing came back negative, and so you suspect there's some sort of infectious disease, but you don't know what. One thing you could do is do some sampling, and just see what's there, some sequencing rather, and just see what's there. But in order to do that, you'd need a really high quality database, regulatory grade database that you have a lot of confidence in. So that's one way that it could be used, for example. And so building a high quality database that is becoming updated with the latest sequences, including, of course, the SARS-CoV-2 sequences, is very, very high priority. And so this is what the database, the front end of the database looks like right now. So each of the genomes and metadata tables describing some of the information in it is represented as a card there. And each card has a BCO in the back end that keeps a record not only of the processing steps, but versioning for each of the resources that went into the QC and data curation. So it's a very elegant system for tracking sequences and quality control steps. Okay, so I'll say just a few words about the BioComputeDB. Hadley is going to talk a little bit more about this in detail, but the basic idea is this is a centralized repository for workflow objects, and it can be controlled by the individual users that are depositing to it. And so the way that works is that users will control their own prefix, and so they have sort of a domain space that they have control over. And so we have two existing databases. One is at GW, and one is at the FDA behind the firewall. And so if, for example, let's say Hadley and I have administrative privileges on our own domain, our own prefix rather, then we can control what gets submitted there. So, for example, in this one, our prefix is GWU. And then let's say I've got two workflows. I call mine Vaccine Kini 1, Vaccine Kini 2. Hadley calls his King Healthy Microbiome Pipeline. Maybe CBER has a different organization and they want to make theirs sort of more like an accession number. Maybe a third institution uses the publication name where the workflow first appeared, for example. And that's entirely up to them. So that's sort of like a namespace that the different organizations have for their own organization. So Hadley and I have administrative privileges for GWU, so we can publish our objects, we can read, write, we can share, we can delete objects, and so forth. But we have no permissions on any other prefix. And so this is the basic idea with this prefix control system. All right, so just about to hand this off. Before I do, there's several folks that I really want to acknowledge. Dinos is Konstantinos Karagiannis and Mark Walderhog and Anton Golikov at the FDA. Hadley King is the technical lead on our end. Tianyi Wang is the outreach lead. You may have heard from her. Rohan Panagrahi and Sean Keeney are were both interns that helped work on the BCO library. Lam Fook has helped work on the redesign and is currently working on the redesign of the portal. John Torcivia Rodriguez helped both with the comparator and with the BCO library. Alhanouf Altuejiri and Michael Crusoe gave us some really important insight into migrating to the Elixir database, and Alhanouf is currently working on that migration right now. And then Stian Soyland Reyes put together that really fantastic tutorial. So an enormous thank you to them and to the BAA from the FDA that supported all of this down here in the corner. And a big thank you to Raja Mazumdar and Bahan Simonyan, who were kind of the founding members who got the ball rolling with all of this and really, number one, identified the need very, very early, many years ago, and then really worked very hard to pull the community together and kind of point out what a big issue this is and how necessary it is and how much unnecessary burden it's creating that we just don't have some guidelines around it. So big thank you to them. And so with that, we will transition to the rest of the workshop. I'll pause, I guess, for maybe, a couple of minutes. Yeah, I guess about 2 minutes for any questions for me. And then I'll hand it off to Hadley King, who will cover the BioComputeDB and portal and prefix system in a little bit more detail. And then Nicola Soranzo will go over the Galaxy portion of it. And then there'll be a break from 12 to 12:30. And DNAnexus will pick up at 12:30 until 2. They'll cover a demo for the BCO Nexus, as they're calling it. And then demo some use cases. And then there'll be a break from 2 to 2:15. And then from 2:15 to 3:45 will be the 7 bridges block, and they will demo their tool and then also demo some use cases. And then at the very end, there will be a 15-minute period for open discussion, questions and answers, those kinds of things, future plans. So please feel free, as I said in the beginning, please feel free to ask your questions in the chat. Those go to the presenters and the organizers. We'll sort of leave it up to the presenters in terms of when they want to answer the question. If it's a quick one, they may choose to answer it right away. If it's a bigger one, they may choose to hold it off until the end here, the open discussion, if they feel that it requires a little bit more discussion. Okay, so that's it. Let me stop sharing here. I'll also answer any questions if there are any while we're transitioning over to Hadley. Find the chat. There we go. Okay, so Hadley, I think you're all clear to go ahead and get started.
Oh, okay. Good morning, everybody. I'm going to discuss the BCO portal and the BCODB. I am going to go through a few slides here, but I know it's a demo on the agenda. So if anybody really wants to see any of this in action in the wild, I'd be happy to do that afterwards. But for the sake of For the sake of everybody's time, I figured I'd just do slides to start. The BCO portal, BioCompute Object portal, is the website that we have at BioComputeObject.org. It is an aggregate of all of the BioCompute resources that have been developed and put together over the years. So we have links out to our documentation sites, links out to other platforms that support BioCompute specifically. We have a BioCompute builder. And for a newsfeed functionality, we also show the BioCompute Object Twitter account on the main page. So using that for announcements and updates to events and new releases to the portal. The BioCompute DB is a separate entity from the BioCompute portal. So it is a database that houses BioCompute objects. We do have a public instance of the BCODB attached to the BioCompute portal. You can see the URL there. This is the API documentation page to represent the BCODB. All of the code is available via GitHub, and anybody can set up their own independent instance of the BCODB, and then actually use the BioCompute portal to interact with that, as long as they set up the appropriate permissions and everything. So actually, at the bottom page, at the bottom of the BioCompute portal, we have a few links here. There is a link to each one of the GitHub repositories that house the code for the BioCompute portal and the BCODB. Contributions are welcome via pull request. And we also, as Jonathan pointed out, have a contact us link, which goes directly to a Slack channel for the BCO team. So somebody should see it if you need like instantaneous, well, not instantaneous. If you need time sensitive assistance, that's your best way to go about getting it. If there's something else you see that you think would be worthwhile to bring to our attention, we have a report bug or request feature option 2. That'll take you directly to a pre-populated GitHub form where you will get instructions on how to submit a either bug request or a feature request. We do look at and monitor the GitHub issues daily, so that's also a pretty good way to get our attention. So I want to go into a little bit of the server information available on the account page. So this is how we are managing the portal's ability to enable users to use multiple instances of the database. This is a screenshot of my account page, personally. I've redacted my tokens because that's sensitive information. But you can see at the bottom of the page, there are 2 different URLs here. One is the public BioComputeObject.org, and the other one is bco.hive.fda.gov, which is an instance of the BCODB that we've set up within the FDA's firewall. Now, the caveat with that is that you have to be on the FDA VPN to be able to access that. But if you are, then you're able to interact with that database and create BioCompute objects there, you know, edit them, publish them, what have you. So this is an example of what we mean by when we say that you can have multiple servers, you can have access to multiple instances of a BioCompute database. The reason that we thought this was a useful feature, and it's been a feature that is, you know, technically challenging, but is because the kind of information contained in a BioCompute object might not always want to be completely public. You know, a particular organization may want to have their own internal database, which they don't share, and so you have the ability to do that. So adding a new server or an additional BCODB instance is fairly straightforward. You just need two pieces of information: your token, which is, you know, like your username and password in one, and then the public host name or the URL for the DB that you're accessing. You enter both of those pieces of information in form, hit verify account. The website will check to make sure that that token can access an account at that server, and if it does, then you can add it and your information will be saved. Once you do that, you will have access to multiple servers. So I have some test examples up here, but when you go to create a BioCompute object, you'll be asked to select which server you want to save it to. So even if you have one, it asks you to select it. But if you have multiple, then you can choose to save that or create a BioCompute object at that location. Once a BioCompute object is created with a prefix at a particular URL or at a particular server, it can't be transferred by what you would think. Like, you can't change the location you save it at. You would have to physically copy that object and create a new version of that at the other server. But the other thing that is server specific is the group functionality. So the groups and permissions associated with objects and prefixes are specific to a particular server. So if you add yourself to a group, say the Hive prefix group, Hive drafters, on the public server, that will not transfer to the instance of the FDA server automatically. You have to have an admin from that particular database add you to that group. So that's something to keep in mind too. So when you're searching the BioCompute objects from the object page, you will see the same thing. It will ask you which server that you have access to. You should select. Right now, the search functionality is very basic. We plan on improving that over time, but there are three main search types. My BCO, you could just click that and you get every BCO that you have ownership of. You could search for a particular prefix, so that would return all of the BCOs with that prefix that you have access to, or you could search for a BCO ID, and this is a partial matching search. So if you know, like, you want BCO number 64, you could just type 64 and hit enter, and you'll get anything that has the number 64 in it. So with that, I'm going to move on to the prefix registry. So the BCO prefix is the portion of the BioCompute object that is before the digits. Just realizing I should have had a good example up here of a BCO prefix. And bear with me 1 second. I'll grab that. Okay, so I'm going to switch real quick to this. Okay, so on our documentation site, we explain how a BioCompute object identifier is constructed. It consists of a protocol, a host name, a BCO accession, and a BCO version. The BCO accession is composed of a digit and a prefix. So the prefix is used to classify the BCOs. The digit is just a numerical value that goes along with the prefix. So the prefixes allow, there are 3 to 5 alphanumeric characters. We maintain a registry of those prefixes, and that allows for sorting of BioCompute objects by a particular function, by a particular user, by a particular company, however you choose to use the prefix. It's a method we've come up with for sorting the BioCompute objects. So back to the presentation. Sorry for the delay there. So we have on the BioCompute object portal, the prefix registry page, and here an account is not required to browse the prefix registry, so you can look through and see what prefixes have been registered, give you an idea of what you may have access to as a user. But to actually register a prefix, you do need to be logged in. So here, this is a screenshot of the prefixes, some of the prefixes we have currently. Out of these 6, only 1 is currently private. The rest are all publicly available. If you are logged in, if you see in the screenshot here, the register prefix is grayed out. When you're logged in, you can click on the button. See, you can see I'm logged in because it has my name in the top right. Create a prefix. Choosing public or private for the prefixes. So a private prefix means that it is saved so that it is restricted, meaning that not everybody in the world can use that prefix. You will have to assign specific users to that groups that have permissions for that prefix if you would like them to be able to use it. If you assign it as public, then that just puts it out there for the entire world. Registering a prefix makes you, as a user, the owner of that prefix, meaning that you can choose to assign or modify the permissions associated with it or the description or other features associated with the prefix. So if you do choose, take that back 1 step. No. Each time a prefix is created, each time a private prefix is created, there are 2 groups, user groups that are created with that prefix. So if I created a private prefix called test, which I did this morning, then the groups test drafter and test publisher are also created. And as the owner of that prefix, I also become the owner of those 2 groups, meaning that I can assign other users to those groups. So for test drafter, I can assign a new user, jdoe58, and then jdoe58 will be able to use the test prefix to create draft objects. The publisher group is for somebody to take a drafted object and publish it. So we found that making the distinction between somebody who's able to create a draft and somebody who's able to create a published object as something useful for the projects that we've been using to test BCO and to for tracking purposes. You know, you want a whole bunch of undergraduates to make you BioCompute objects, but you only want the postdoc to be able to publish them. You know, you want somebody to check it over before it's actually put out there. So that's the reason for that distinction. The prefix owner must be the one to add the users to the group, and the groups and the users are server specific as well. So I kind of covered that earlier when I showed the two different, the example of the two different servers, but each instance of the BioCompute DB is its own contained ecosystem. So they currently do not communicate with each other and probably won't. So you have to manage it on an instance by instance basis. And then the other thing is you must use the BCODB username, not necessarily the username from the BCO portal. Now it can be the same some tech cases, but not always. So in the prefix registry, searching for a specific prefix, searching for specific prefix with the BioCompute objects. So this is the object page. It's biocomputeobject.org/objects. This is where you would find a list of the objects contained in the database. Again, you select which server you want to search. So right here, this is the public instance. And you can sort by the various columns that are listed here. So sort by the state, whether it's draft or published. You can sort by the prefixes, but here we're doing a prefix search. So we're searching for all of the Argos database items. The last updated time, and also BCO session. Again, as I said earlier, the prefixes can help you to organize BCO into specific categories. You know, for this, we have different research projects that we are using BioCompute for, and that allows us to differentiate those objects among the different projects. So creating a BCO with a prefix, again, it's pretty straightforward. I have two examples here. I was logged in as John Doe on the left-hand side, and John Doe does not have permission to use the test prefix. So I was trying to create an object with the test prefix as John Doe, and I got a failed error. Token provided does not have permissions for this prefix. Now, John Doe did have permission for the Galaxy prefix. So when John Doe created a BioCompute object with the Galaxy prefix, we got a success message. This is for creating an object, as I said earlier, it's based on the draft permissions. So if you are part of the group, the prefix, so in this case, test, drafter, John Doe was not, Galaxy, John Doe was, so he was able to submit a Galaxy object. This functionality also applies to the publisher group for each of the prefixes, as I said earlier. All right, so that's pretty much it for the prefixes for now. I am going to move on to the BCODB and API. So the BCODB, all of the functions associated with the database have been published in API documents. There are two different versions of the API docs. They're at different URLs. This is also straight out of the box. So if you downloaded the GitHub repository and set it up, you would automatically get both of these at the respective URLs associated with each one. So for the Redux, it's your base URL /API/Redux. For the Swagger documentation, the one on the left here, it's API docs. And I'll go into why there are two different versions now. So Redux is designed specifically for readability, has a standardized layout for all API commands, and a lot of people find the 3-panel layout to be extremely easy to navigate. So on the left-hand side here, you have all of your main categories, just like most table of contents we're all familiar with. You can select through each of the categories and each of the functions here. The main page lists what the function is. It gives you the request schema, and it'll also list the responses. So these are the responses you can get back from the server. And then on the right-hand side, you get the actual URL for that API request and example payloads that you can see. So Redux is like I think it's pretty elegant looking, but it's just straight documentation. So it's great for that function. The Swagger documentation has a different function though. This is actually designed for usability. Again, it's based off of the open API schema, just like Redux, and it automatically generates these pages with a little bit of TLC. This one, the Swagger is organized by collapsible endpoints. So whereas with Redux, you have your menu on the left side, with the Swagger, you have your menu horizontally. You can collapse account management. You can expand each of the individual functions. Now, the main value with the Swagger is that it's actually functionally interactive. So you can take via the web browser here, you can actually use the API commands and test them out. So this is an example of one of the functions. It's one of the simplest ones. API accounts described. So it basically just asks for the permissions associated with a particular account and what they are able to do. So for this, you just enter a token and then hit execute. And you can see here, it gives you the actual curl command, it gives you the actual curl command that's run. So this is what is submitted to the database with the headers and as such. It automatically generates all of the headers and the formatting for you. So you could actually copy this into a terminal, run the same exact thing and get the response back, but it's good for development purposes. And then you can see here on the right-hand side, I included what the response is. So you get the response back. It tells you the host name. It tells you what the permissions are for that user. And then you see the response headers down here in the bottom. So for folks looking to plug into a BCO-DB with other applications, this kind of format is extremely useful and great for testing and development. And then the last thing I wanted to talk about is the BCO bulk validation. So again, I'm using the Swagger website to show this, but it is available via this URL. Might find it easier at first to use the Swagger site to set up how the request should be formatted, but if you're comfortable with that kind of thing, you can just freewheel it. Sorry. So this requires no authentication. So you don't have to be logged in. You don't have to have an account. You can just submit a request and it'll return a validation for any BCO. It's also, you can do it in bulk. So you could submit multiple BCOs at once and you get a response back with a separate JSON, with a JSON object that contains the results for each BCO. So what do I mean by that? I submitted 2 BCOs here in this example. And you can see here, this JSON object is divided by the object ID. So Galaxy 001 and test 0001. The test object was actually a published object, so I knew it was valid already. That was the whole point. And you can see it returns no errors, BCO valid. It also does validation for the extension domain, and if the extension domain comes back valid, it says extension valid. This Galaxy object, however, I knew was incorrect, and I submitted it, and I got back the E tag, which was an empty string, does not match the desired format, and the same thing for the execution domain. There was a blank environmental variables, and it's a required property, so that was kicked back. So for each object you get, or for each BCO submitted, you get back a little dictionary that includes a error message for each part of the object that was invalid. And that was it for my portion. Questions, comments?
Okay, thank you very much, Hadley. That was terrific. And as he said, he provided a number of links, so please feel free to go explore some of those, both at the portal and the API links that he mentioned. Okay, so we'll, I think, move now to the last section of our beginning block, the intro block, which is Nicola Soranzo, who will be talking about BCO on Galaxy.
Thanks, Jonathan. Can you make me presenter? I can share.
We can. There we go.
Thanks. Right, so hopefully you're seeing my screen now. So first of all, just a quick introduction about myself. I'm Nicola Soranzo, as Jonathan already introduced me. I work at the Erlam Institute in Norwich, and I've been a Galaxy core developer, and also tool developer and trainer for a number of years now. So today I'm going to give you just a quick introduction about how Galaxy works, what's its aim, and how you could interact with the BCODB and submit analysis that you do in Galaxy to the BCODB. So first of all, what is Galaxy? I hope many of you already know about it, but for the one who don't, Galaxy is basically a data analysis platform, which is web-based, so you interact with it as you normally do with any website through your web browser. And its main goal is to make data-intensive science easy to use for people that are not very familiar with the command line or that like to work in a web environment and automate their analysis through workflows. It's completely free and open source. I'll show you later what are the main ways that you can have to use Galaxy. There are several freely available servers for Galaxy that you can use for free, but you can also just download it from its website and install it for your own use or for the use of your local lab or university. So its main goal is to basically to integrate as many as possible tools. For example, its core stories basically was coming from bioinformatics, computational biology. So that's where most of the tools that are available in Galaxy come from, but it's been extended to several other domains. You can just, if you are administering one Galaxy server, you can just install from a publicly available toolshed and integrate them easily in your Galaxy. It's heavily cited tool, Galaxy itself, and the various servers that are available, and the tools, etc., with more than 11,000 publications. Another great point is that it's very easy to learn because it has a lot of tutorials and courses that are given by people all around the world using the training materials that I'm actually using today for this presentation. I will also give you some links later on of where to find it. So why would someone use Galaxy instead of other tools? So first of all, the main goal of Galaxy is to make data analysis easy. It doesn't require, unless you want to install your own, any installation. All you need is just your web browser to interact with an available Galaxy server. You don't need to learn how to use the tools on the command line. You just use your mouse and point and click. Another core value of Galaxy is reproducibility. So without you having to do anything, Galaxy keeps tracks all the things that you do while you use it, which tool you use, which parameters you use while you run the tools. If you compose these tools in a workflow, it will track when you run the workflow, on which data you run it, and the outputs, etc. It's all integrated, and it makes it very easy to share your results with others, or to simply go back after you finish your analysis some years later, or share it with others, and you can see every step that you've done. You can redo the analysis exactly as you did it the first time. And I was mentioning that it started mainly from bioinformatics, but it's been integrating tools from chemistry, ecology, climate science, and several other domains. So how do you use Galaxy? So there, as I mentioned, there are a number of publicly available Galaxy servers. In particular, there are three main ones, one based in the US, the so-called Galaxy Main, one in Europe, use galaxy.eu, and one in Australia, use galaxy.org.au. And these cover these three large portion of the world, but there are many other, more than 130 freely available Galaxy instances or servers that you can use. Many of these are domain specific, so they're concentrate on tools for a particular domain. The protein science, for example, there's a Galaxy Proteomics server that's heavily used for proteomics, or could be simply a local server run privately for a researcher in a university or an institute. How does it look like? So that's a screenshot of the Galaxy interface, and it's divided in three, at least the normal that I'm showing, normal interface I'm showing here right now. When you start to use it, in three panels. On the left-hand side, you have the list of tools that are available, divided in sections. In the center panel or middle panel is where you view the results of your analysis, so you visualize, or you have the main interface. When you select a tool, it will be shown there. And instead, on the right is where all your data appear, so the one that you upload to Galaxy, or you download from some database, or the data that are produced when you run a tool in Galaxy or a workflow. How do you start your first analysis? Normally is by uploading some data that you want to analyze. You can either upload data from your computer, so if you have your data locally on your laptop or something like that, or if you know some public data that are available at a certain URL or internet address, you can just paste it to the upload interface of Galaxy, and Galaxy will download it behind the scenes, so you don't have to first download and then re-upload the data from your computer. And it also has Galaxy several integrations with various databases like the UCSC and CBI, DNA, etc., that make it easier to directly download data into Galaxy from these data stores. So once you have uploaded somehow from one of the methods that I mentioned your data into Galaxy, they will appear on the right-hand side of the history panel. It's called the history because it keeps tracks of all the various steps that you do in your analysis, and that's kind of the core of the reproducibility of Galaxy. Once you have some data there, there will be numbered, and so you have first data, then that data will appear in number 2, 3, 4, etc. So you can easily refer to them. And for each data that you have loaded or created in your history, you have several actions you can do. There is an eye icon that you can use to visualize the content of the file. You can edit some attributes, for example, change the name of the data set, or its data type, or various properties. Or there's a delete button when you want to get rid of it. And for each of these data, you have several other metadata or data information, like how big is this data set, a small preview of the data without having to open it full size in the center panel, and other options to download it back to your computer, or how it was produced, and the various metadata that Galaxy collects for the reproducibility. So once you have some data loaded in your history, the next things that you normally would do is start doing some analysis using one of the available tools, which again are shown normally in the left panel. You can search for tools using a search box. That's kind of handy because especially in the big servers that contain hundreds of tools, it's quite easy to get lost in the various sections if you don't know where exactly a tool has been placed by the administrator. So using the search box make it easier to find the tools that you want. Later on, once you find a tool that you constantly go back to, you can also add it to your favorite or star it. And then when you have selected the tool, it will appear in the center panel, and it will give you several options. First of all, it will ask you to choose some input files, the one that you have loaded into the history before, and then select various parameters. That could be some text options, could be some numbers, depending on the underlying tool that's been wrapped into Galaxy in the web interface of Galaxy. And then when you click the execute button at the bottom, behind the scene, what happens is that Galaxy will take all the information that you've put in this form, so the input files, the parameters, etc., and will assemble a command that will be normally scheduled on a cluster or some cloud resource to run this tool for you. Once this execute button has been pressed and Galaxy start running the tool, what happens is that a new dataset, or more than one dataset if this tool produces several outputs, will start appearing on your right-hand panel, so the history. And the new datasets that being produced by the tool will go into several stages or dataset states. The first one is waiting for the resources to be run on the cluster, and then will be started to be running in orange color, and then it will be either going in a success or green state or failed state in red, if there's was some problem with their input, or when it's running on the cluster, some error can happen. And then again, you can decide to download or visualize the data set. There's also a very important button that you will find useful is the reload or rerun button that basically put again the information that you have put initially in the tool form in the center panel, so you can rerun with the exact same option, maybe changing one parameter or changing one input and see what happened. And there's also a bug icon if you have a failed data set, you don't know why or what happened, then you can submit automatically a bug report to the administrators of the Galaxy server. And I mentioned that you can visualize data, so it could be simply just view the content of a file if it's a text file, but many data types have integrated visualizations. So if you have some kind of sequence alignment, you can visualize it as a like in the top left here, or if you have proteins or mRNAs, you can do some 3D visualization or other type of graphs depending on the data type of the data that you have created with the tools. And another important thing is that we really recommend people to create separate histories for each of their analysis. So give it a good name so you can find it back later on, and don't mix different analysis in the same history. So that's helped with the reproducibility and also in finding your data later on. And then if you have connected analysis, you can easily view them side by side in a multiple analysis or multiple history view, and even drag and drop a data set from one history to another in this multiple histories view. And another very important feature of Galaxy that will come back also when we talk about the BCO submission is workflows. And basically is used to connect several tools one after the other and create a so-called pipeline or workflow. You have several ways to create a workflow in Galaxy. You can do an exploratory analysis by running one tool after another, just I was telling you about earlier. And then when you're finished and you're happy with the result of your analysis, you can extract it automatically, just using an option of the history. And Galaxy will create a graph like this. And you can just maybe give some cleaning to it, naming the various inputs in a meaningful way, adding some metadata to the workflow, and you're done. Or you can start from scratch instead of doing the exploratory analysis if you really know how your analysis is going to look like. You can just take the tools from the tool panel and add and drag and drop the arrows that connect them, and that will be just the connecting the output of one tool to the input of the next one, and this will be the flow of data through your pipeline. Workflows are really handy also because you can simply start a workflow, give it the input that it needs, and then go do some other work, take a coffee, go for lunch, whatever, depending on how long the various tools take. You can also set that at the end of the workflow, you can receive an email, and then you don't need actually to stare at the screen waiting for your tools to run. You can, again, share a lot of the things that you mentioned, in this case, workflow, you can share with other people. And you can also embed a workflow inside of another workflow as a so-called sub-workflow. So you can create smaller units that you can reuse in various workflows. For example, some quality control that some type of data may need, you can reuse it in various workflows that use the same type of data. And so speaking of sharing, you can share basically everything that I've mentioned till now. You can share histories, you can share a single data set, you can share workflows, visualization, everything. You can share either with a specific user or users, or you can share like you would do with a Google Doc via link. Or the third option is that you basically publish it. That means that everyone that goes in the share data on the top menu of Galaxy will be able to look at it and import it and reuse your analysis, being that history over workflow. At the very start, I said that I'm using material from the training material of Galaxy. There's a website which contains a huge amount of training material. It's training.galaxyproject.org. It contains various material for various topics. So all of the various bioinformatics and computational biology that I've mentioned, but also climate science and the other domains for Galaxy are covered from a user point of view, but it is also how to manage your Galaxy if you want to be a Galaxy administrator, or how to develop Galaxy tools, all these kind of more developer-oriented topics. So there are 28 of these different topics. The total number of tutorials across the topics is almost 300 right now. I think the testament of the success of this initiative is the huge number of different contributors that have helped us in creating this huge amount of training material, so more than 250 contributors. And this project has lasted already for more than 7 years, just the training. So how you can get help if you get lost? It is not only the training material, but there's also a forum that is available at help.galaxyproject.org with already a huge amount of solved topics that you can have a look, or open questions. And the other option is to go on, try to chat with the helpers or developer of Galaxy. And there's a link here to the main Galaxy chat and the one for the training material. And then there is more specific channels for certain domains, scientific domains, or one dedicated to developers and admins. There are several events that are run during the year that are related to Galaxy, and they are all listed at galaxyproject.org/events. And this could be either training or workshop, conferences, etc. We have a big event called the Galaxy Community Conference that run every year in around July, and next year is going to be in Australia. So if you want to do a nice trip to down under, that's your occasion. And so that's the general introduction to Galaxy. And now to connect with the topic that Adley just spoke to you about, I want to show you a couple of slides of how you can, once you finish your Galaxy analysis and you want to export this as a BioCompute object. So the main feature that we have integrated is to export what is called a workflow invocation. So if you create a workflow somehow, give it the input that it needs, you run it, you wait until it finishes, and this is a completed workflow invocation. This is a workflow run. And you can list all the workflow invocation that you have done by going to your user menu once you have logged in Galaxy. And then if you scroll down, you can see in the picture, there's a workflow invocation under the user menu. And this will list all the various invocations of the workflows that you have run. And you can expand one of these workflow invocation. You can see it now in the next slide. And there are several tabs, one that summarizes the workflow invocation, then there are more details about the various steps of how the workflow was executed. And there is the third tab, which is about exporting. In particular, there's a possibility to export the workflow invocation as a BioCompute objects. This could be exported in basically two ways. One is to download it as a JSON file to your computer, or just show it in the browser. And the other is to submit to one of the available BCO databases. You can also download your BCO directly through the API of Galaxy. Galaxy is an extensive API that lets you drive basically everything that you can do as a user directly from the API. So it's not simply a simple way to use tools in a web interface, but it's actually a powerful instrument that you can drive through the API. And we have used this system to run a giant COVID analysis during the pandemic. So going back to the BCO, I've listed here the API /API/workflow/workflow ID/invocation ID. So you get this information from the API, and then you just add /BioCompute, and you will have your BioCompute object downloaded. Otherwise, if you, instead of downloading, you want to submit it to a BCODB, what Galaxy does is something similar to the draft BCO that Hadley showed just before my talk started. You need some of the information to add to the BCO export functionality of Galaxy. In particular, your username and the token or API key, as you like to call it, for the BCO DB that you want to upload to. And you just fill some other field like the prefix. Again, it was introduced by Hadley. And then you're done. You just click the submit button. You will, what Galaxy does behind the scene is to interact with the BCO DB API for you using the token to authenticate and submit the draft BCO object. And you will get the ID of the BCO object in a pop-up. And you can copy that, and then you can search. So you move to another tab of your browser. You go to the BCO database, and you can search for this ID, or you can just list all your BCOs and just find it by the name that it's getting from Galaxy. And I think that's all, and I'm probably good on time for some questions if there are, or just to conclude the session.
Hey, Nicola, we do have a question from Coleman asking if he can use Galaxy in order to do biostatistics analysis.
Well, I'm not an expert in biostatistics specifically, but I can point you and give you a link to the main Galaxy to have a look if there's if you know which tools you want to use, then you can look at the available Galaxy servers to see if the tools are available, or you can search on the Galaxy toolshed. Again, I can share the link on the chat once I found where it is. Okay, it's there. Yeah, and there you can basically find all the tools that have been created or wrapped from the command line tools that normally other people use. And yeah, that's the just put in the chat. All the participants can access the chat, right? I think so. So that's these are where you can find all the tools that are already freely available to Galaxy, and many of these are already installed in one of the big three Galaxy servers that I mentioned at the start. So the Galaxy main, or use Galaxy.eu, or the Australian server.
There's also a statistics subsection in the Galaxy project training materials site too,
Yeah.
Which would probably be a good resource for that.
Yeah, good point.
Okay. No other questions, Hyunyi?
No, I don't have any other questions.
Okay. Excellent. Thanks a lot, Nicola. So we'll take a lunch break now, reconvene at 12:30 and get started with the DNAnexus section. So thank you to everyone, and we'll see you in half an hour. right, so welcome back. Let me take down this slide here. And we will get started with the next section. So I will also, while we're getting switched over here, just take a minute to sort of directly connect the dots between Hadley and Nicola's talk. So Hadley was talking about the access-controlled BioComputeDB and the prefixes, and Nicola was talking a little bit about building and using BioCompute objects on Galaxy. And so just to sort of draw a more direct connection there, the implementation of BioCompute objects on the different platforms will have a connection to the access-controlled DB. And I think that the next presenters will probably say a little bit more about that more explicitly than the last one. So just to kind of make that clear. So let's see. Next up is DNAnexus, and that'll be Omar Sarang and Sam Westrike. So I believe we've already made them presenters. Let me just double check. There we go. And so I think we are ready to get started as soon as you guys are ready.
You hear me, Jonathan?
I can, yeah.
I can't seem to start my video, but I guess there's no reason for that. I just have to share, right?
Sure, yeah. That's interesting. You can't start your video.
Start my video, yeah.
Okay, let me see.
Oh, there it did. It just did. Great. All
okay,
right.
Great.
Hello, everybody. Thanks for taking the time. I'm looking forward to sharing BioComputeNexus with you. We started working with the George Washington University group on this some time ago, and our Seven Bridges and Hive colleagues. And it's been really interesting, as Jonathan said, to see the different approaches being taken here. And it'll be exciting to see the Seven Bridges approach after ours this afternoon as well. So I'll start right out here. In fact, what I'm going to do is shut my window here and get rid of some of this background noise. Apologize for not being better prepared. It's one of those things where my Google Drive wouldn't come up and lots of things like that. One of those days. But let me know if that's working.
There we go.
Oops. All right. Everybody see the slide?
Mm-hmm.
Great. So BioComputeNexus is a platform-free editor. What platform-free means is it just runs in a Docker image. You can run it pretty much wherever. It doesn't depend on any particular operating system externally. It has everything it needs packaged up to provide a web service directly from your running Docker image. So the platform-free editor will ingest WDL, CWL, as far as workflows to populate the relevant domains in the BCO, and of course can ingest a BCO file directly as JSON. We can also ingest DNAnexus workflows. So the DNAnexus platform is a bioinformatics platform similar to Seven Bridges, where you can manage data securely, deploy software and analysis, create workflows, whether from WDL, CWL, or natively, and you end up with a workflow represented on the DNAnexus platform. And like our Seven Bridges colleagues, we have an API that exposes how different objects underneath it, and the BioComputeNexus will reach the DNAnexus platform by the API and extract workflow and application data in order to populate the parametric and IO domains. So you have a number of different ways to bring data in. Everything is driven off the BCO schema. This was foundational to our design approach. Essentially, the navigation and everything else is driven off the schema. And you'll see the tooltips and other things are also fed off of the BCO schema. But we wanted this to be entirely structured. And in other words, we don't have a bunch of logic for navigation trees that attempt to map the schema. We use the schema to define the navigation, and you'll see that as evidenced through the UX. We can also output to a JSON file, and we can output directly to the BCO repository. Obviously, with the interaction to the DNAnexus workflow and the DNAnexus platform and the BCO repository will require the access keys be entered by the user in order to interact with those resources. Last but not least, you can export from the BCONexus platform to the DNAnexus platform as a workflow, and it'll extract the BCO itself and instantiate a workflow based on WDL or CWL. In order to be able to export, you have to have the script be defined as a WDL or CWL so that the DNAnexus platform can interpret that and deploy the workflow based on the workflow serialization language. Just a quick overview of the BCONexus user interface. As you can see, there are build, review, and export main functions at the top and a search function. The search function is not a data search function, it is a key search function, but it's really nice for quick navigation into a specific BCO keyword, whether it's script or input parameters, but you have to put the exact schema defined keyword in for the BCO key, and it'll navigate you down there. I kind of like to think of this as more of a surgical tool in a way, and the point behind this was to maintain an in-memory document. So you have this BCO document, and it sits in memory, and I wanted to be able to manipulate it, visualize it, review it, validate it, and most importantly, I wanted to be able to layer sources of the BCO from various different pieces, like maybe pull in a workflow with WDL, and then perhaps add a provenance domain from JSON. But the idea behind this was to be able to build an in-memory document from multiple sources or a single source, and then to export the resulting document and to be able to validate and review it. So this is the build screen. You can see the top level domains of the BCO. The little eye bars will bring up the description of each of the domains from the schema. The review, this is what I was reflecting as you can upload your file. So the three buttons at the bottom here are really pretty important. As you can see, we can pull in from the sources I mentioned, but the reset button clears the in-memory document image, pretty much wipes it. If you export it, you get a bunch of BCO top-level keywords with empty fields. The load does as you would expect. It will take whatever document you bring in, essentially perform a reset, and then load the document up and populate the in-memory document image. Everything is in memory, it's pretty immediate, but the other key thing here is the update. And this is what I meant about layering. You could take say you had like a standard set of reviewers that are working on a bunch of projects or a bunch of different applications, but you have the same set of reviewers that do the same role. You could have a provenance only BCO stub essentially, and then bring in your application data from a platform or from WDL and fill in other things that you wanted, and then update the BCO with the provenance. And what that will do is layer the provenance BCO domain in with the existing document in memory, hence combining them. So you really have a lot of flexibility in how you layer in different things. This is the review screen, and it allows you to see basically schema level validation and to navigate quickly down into areas where the schema level validation is throwing a fault. Lastly is the export to a BCO file. That just downloads the JSON file to your local system, export it to a DNAnexus workflow, or interact with the BCO repository that's run by GWU, and deposit the BCO object into that repository, again with your keys. Layered updates, I mentioned, reset to clear the in-memory document. Sam, I assume you have BioComputeNexus running. I'm probably going to switch over to you just for a quick little walkthrough on a couple things.
I actually don't have it running because I'm going to show how to set it up.
Oh, indeed. Yes. All right. Never mind. I did reflect again the layering into the in-memory document and then exporting it. This is a really powerful capability of DNAnexus, excuse me, BioComputeNexus, because it allows you to take different pieces of the BCO and systematically integrate them. It is schema driven, all the navigation, all the tooltips, everything you do through the editor has an immediate effect on the in-memory document. There is an undo function, Command Z, for text, although it doesn't really work for some other things. Deleting rows is possible by emptying each of the fields, but that's a little clunky, and we're going to make that a little more friendly. And I mentioned the searching for BCO keys. The integration with DNAnexus is, again, to import workflows and apps and their metadata for the appropriate BCO domains, and to be able to export the scripts through the DX compiler to instantiate them on the platform. Sam is going to be working through a bottoms-up demo, starting with the install, which is pretty straightforward as a Docker container. We have a bioinformatics pipeline called SmartSeq2, which we deployed as a WDL a priori on DNAnexus. So there's a DNAnexus workflow for SmartSeq. Sam will show how we install the tool and then load that workflow up and generate a SmartSeq BCO with a whole lot of other different things that go into that. So Sam, I'm going to let you start and then maybe take over for just 1 second to show the layering effect and just the general UX. Why don't you go ahead and start the install, because my computer restart kind of worked me here, but I'll have this thing running in just a second.
No worries.
Sharing.
And then let me go ahead and share. And hopefully we can see my screen. Looks like it's going. So yeah, for everyone on the call, just really briefly, I'm Sam Westrake. I'm a senior project manager at DNAnexus. And I'm happy to get to talk about our BioComputeNexus editor that we've built. So really briefly, installing this is very simple because we distribute it as a Docker image. So I've got just a file window, and so we have it, and we are going to have the links come out, I think, shortly after this workshop finishes. So stay tuned for that. But we distribute it as a tarball, and all you do is you download this and you load it into your local installation of Docker. So I actually have Docker running already. If I swap over here, we can see here's my Docker, and you can see right now I don't have any images running. The engine's running, but none of the images. And so loading this in, I always do it by the command line. It's really easy. In here, all we're going to do is we're just going to do Docker load and then give it -- input and point it to the BioComputeNexus tar file. Really simple. I actually loaded it in already.
Point of clarification, it is the tar.gz, works just fine. Docker, the load works just fine with the tar.gz.
Yeah. And then if I go back, I actually don't want to run it from here. I always like to run it from the command line just because I like to track something to see how it goes. So it's really easy. Just once you've got it loaded into Docker, Docker run. I always like to point it to port 8000. This loads up in your web browser. I just happen to like port 8000 for that. And we'll do BioComputeNexus and point it to this one to load. We hit yes. And then it says it is going to, oh, I think I changed the name.
Sam, can you segue for just a second? I got mine running and I'll just finish up my part.
Sure. Let me just then stop sharing and I'll bring it back just once it's running.
All right, can everybody see my BioComputeNexus screen?
Yep.
All right, so the first thing I'm going to do is I'm just going to reset the image. So the in-memory document's cleared. If I go into my execution environment, there's really nothing in there. We have a little minor bug with the counts here where it shows up as a 1 when it really should be a 0, but we'll get that cleaned up. But what I'm showing here essentially is there is nothing in here yet. I'm going to just do a quick demonstration of the layering effect I was talking about. And I'm going to pick a BCO file that has everything but provenance, all but provenance JSON. And I'm going to load it. So this is a clean document in the in-memory image. And if I look under the execution domain, I now see a bunch of things. And just to take a minute here, you can see I'm navigating the schema. So I'm going to hop down execution. You can see the breadcrumbs up at the top here. Now I'm going to drive into this array. And at any point here, any of these links here will bring up the tooltips, which come right out of the description from the schema. We're thinking of probably adding a button so that the tooltips are optional, so you don't have all these links. I keep hitting on these links and getting the tooltip when I really want to just hit the drill down here. And if I drill down into this, we can see all of the different software prerequisites. So this is a whole array. I could add a row, I could update a date, time, or things like that. But everything I'm doing in here, all I'm doing is messing with the in-memory document. And so everything happens just when you do it. So you really are just sitting in here surgically modifying this document. But to my point again about layering, if I go out to my provenance domain here, you'll see it's empty. There is no provenance for this BCO. I think parametric probably has, no, parametric didn't. What other thing was in here? IO had some things. And again, you're watching me navigate down through the BCO document, and then I can use the breadcrumbs at here to navigate back up. I'll just do another quick demonstration of that search so you can see what I meant about the quick nav. Let's do input domain here. Oh, like that. Oops, that's why. It'll take me right down to that specific key, so you can use the search to do that. Now I've got no provenance, but I have a nice boilerplate provenance that I use because I have all these same excellent reviewers from GWU that are going to help me with this. I'm going to choose the file with the provenance and update, not load. So now you'll see all my execution and other stuff is still there, but I have all the provenance that I'm looking for with all these great reviewers. So I've just literally taken two pieces of a BCO and merged them together. I think that covered most of what I wanted to do sort of introductorily. Again, you just sort of start typing in here. If you need to add a row, you just add a row. This is another reviewer from today. Then if I wanted to see what my contribution is, reviewer contribution, let's say I'm going to be, I created it and created with, you know, things like that. But again, you'll notice that as I nav through here, where's my reviewer? And you can see my reviewer got in there. So again, I'm just sitting in this in-memory document, modifying it and navigating through it. And then finally, of course, you can export it as a BCO file, and then it'll just downloads it straight to your desktop. Okay, that's all I really wanted to get into. Sam's going to really show much more about this, but I really wanted to drive home the concept of layering, the in-memory document editing concept, and the ability to pull in from different sources and to export to different destinations. So I'm going to start sharing and turn it over to Sam for the real presentation.
All right. So let me go ahead and now share my screen once again. And so I realized my issue. I was trying to run the Docker tar file, not the Docker image. So now I'm just going to start this running. And so once installed,
Sam.
yeah, cup of coffee is wearing off. So once this is running, I just start this, and actually if I switch back to Docker, when this refreshes, it'll actually show that I've just started this guy running. And so then what I can do is once it's running, it says starting it at port 8000. So I'm just going to come over here. I'm going to go to just localhost 8000. And when I do, you can see it loads this up. So BioComputeNexus, this app will run on any system. Omar is actually using a Windows computer right now, and he's running it no problem. I am doing this on a Mac. You can probably see from the little Apple icon up here, and it runs no problem. It should work just as fine on pretty much any system as long as you're able to just load a browser where it's displayed at localhost. So Omar showed that once you have this running, you can build a BCO in here from scratch. What this has is every edit and every update that you make is all stored in this in-memory document, as he referenced. So when I click on description, you can see there's nothing in this description right now, but I could add a row and I could put in steps, and nothing is saved into a file just yet. This is all just in local memory. So I can go through and I could build a BCO entirely from scratch in here. That's probably going to take a decent amount of time. It's actually really fun. You can see every time I move or do something, you can see it actually updates, and so you can see the full log of everything over here. But generally, what I would say is you'd want to load in an existing BCO or an existing CWL or WDL file. So when you click on this source right in the middle, it gives the option to choose, and you can load in WDL files, CWLs, BCOs, and you can either load them from local. So right now when I select BCO, when I click on select workflow type, as Omar showed, it just brings up the ability to select a file that happens to be on your local machine. So I could select this JSON and I could load this in. But what we also have is the ability to load in workflows from DNAnexus, which I think is something we really want to show off because it's a really cool tie-in to be able to connect all of the work and analysis that you may perform on DNAnexus with this BioComputeNexus ability to then get those workflows as BCOs, and then to be able to export them, modify them, merge them if you're going to be combining multiple BCOs to make one overall BCO object, and then export that out. So when I select DNAnexus workflow, it will say then get projects, and in order to access DNAnexus, it needs an access token. So the way this works is if I actually switch over, I've got DNAnexus loaded up in this tab because I'm prepared. So in DNAnexus, you have various projects that you set up. On DNAnexus, you can have any number of projects. Each project has its own membership. So if you are working on a number of different projects with different collaborators for each one, you would have each of those experiments be its own DNAnexus project. And this way you can segregate everything. And then under your profile, if I go to my profile, there's the option to generate an API token, which is then able to grant programmatic access to your DNAnexus account. So if I go in here, don't look at my email. You can email me if you want, that's totally fine. But so under API tokens in here, I'm able to create any number of tokens that I choose. And so each of these tokens will grant API access to DNAnexus to whatever application I give it to. You can see here, this is the one that I've actually generated for this particular demo, and I only gave it access to one project. I give it access to this demo project that I set up. I could also set up an additional token that has access to all of my projects if I'm going to be doing something on local where I want to be able to grant access to everything. And then I'll just show when you go and you create this token, you can set any expiration date. By default, it's 1 month, but you could set this to be 10 years if this is going to be a token that you're going to use for a long time, or if this is something you're sharing with a collaborator, but you don't want them to have access beyond 2 weeks, you can set that to be whatever value you choose. And then once you generate the token, it appears as an alphanumeric string. I actually have one that I have already pre-generated, which I'm using for this. As I show, it's that one at the top where it gives contribute access to just this BioComputeNexus demo project. That's this project right here. And so when I come back to BioComputeNexus, I can just paste that access token in. And then when I say get projects, this will send an API query to DNAnexus. And I can then select from all the projects where this token has access. In this case, it's just this one because I restricted it. In this project, I can select any workflow which is in this project, and then I can select an analysis run of that workflow in order to load in. So what you're seeing here is actually API queries of my DNAnexus project. In here, I actually have this workflow. You can see here is that multi-sample SmartSeq2 workflow. And if I was to click on this, when this opens up, this is actually a full complex workflow. This is used for doing single cell analysis, and it has a number of different steps in here. If I take a look at like the stage settings, you can see that this has a whole bunch of configuration options where it takes in, it checks arrays, it has various aligners, so you can set whether you want this app to run either Bowtie2, this one is star, this one is HiSat2, and so you can actually toggle when you launch this array which of these different aligners you want to use. Then after it finishes, it aggregates all of the results from whichever aligner you selected, and then it has another output step that combines and provides all of the final outputs. So on DNAnexus, this is a great place to maintain individual workflows. You can see I can even mouse over and I can see all of the inputs that flow into this. I can see all of the intermediate files that are going to be generated at each stage. And then I can see all of the outputs that will come out of this, BAM files, BAM index files, and one more output that's down here. And so this I can run on DNAnexus. I can use this in order to analyze all my data. But then maybe after I've done all that analysis, I want to take this workflow, I want to publish this as a BCO. I want to put this out there so that others can see it, others can use it, others can load this up. You can actually import BCOs into DNAnexus to set up a workflow. But with this BCO Nexus, this makes it very simple and very straightforward in order for me to get this workflow out. So the workflow right now is on DNAnexus. What I can do is in here, I can say, okay, I've selected that workflow, and I load that in, and it will again use the API to connect to DNAnexus. It will load in all of the parameters for that workflow. And so now if I click into description, for example, I can see all of the pipeline steps for that workflow on DNAnexus. If I go back to home, if I take a look at parametric, I can see all of the inputs for this particular execution of it that I loaded in. So I can see, here is the file link on DNAnexus that's loaded in as the annotation GTF file. I can always click into here and edit this. So if it turns out that this is actually, RZ, I can make changes to this and I can update this. And all of this, again, this is all saved in working memory. So right now it's all loaded in and it's just loaded into BCO Nexus. Then once I've loaded in, maybe I want to add an additional set of data. Maybe if we talked about provenance, as Omar talked about, right now under contributors, there's nobody listed. So maybe I have a bunch of existing contributors, which I got out of an existing BCO. I want to load that in. So as Omar showed, this tool supports layering. So I can say, take a BCO and let's grab a local one. I can take this provenance only BCO where this BCO just contains a bunch of information about various contributors. I can say, open this one, provenance only.json, and when I click on this update button, it does not remove the existing BCO information that's in memory, but as Omar showed, this adds onto it. So this way I can merge multiple BCOs together. Now, if I take a look at parametric, you can see it still has all my values from that SmartSeq2 workflow that I loaded in. But when I go back here and I click on provenance, now we can see that it has all of the contributors and all of the reviewers that were in that provenance BCO. So this is really great if you are working with multiple BCOs and you want to merge them, or you want to take components that you have in a common BCO. Maybe you build one and you're like, I'm going to be exporting 10 different workflows, but I know that for all of them, they have the same contributors, the same reviewers, and the same the same basic information, the same licenses. You can set up one BCO that has all of that common data in it, and then save that, and just save that as your BCO file and say this is a partial BCO that contains contributor information. And then every time you build a new workflow, you can use this tool in order to layer those BCOs together in order to create one common merge BCO that you can then export. Just to show, here's all of the folks in here for all the contributors. And so now my in-memory BCO contains data from both my DNAnexus workflow and from that BCO that is provenance only that I loaded in. Now, when you load in various files, you may also want to do a review. You may want to say, actually, do I have all the fields complete? How complete is this BCO? I started with this DNAnexus workflow, and that may not have had all values specified. So that's where this review tab comes in. And this is really great because this goes through, and for every single domain, this will actually do a check and check a number of values in order just to make sure that they are proper for a BCO. Because if you have a WDL file, a WDL file may not contain provenance information. So even though it's a perfectly valid WDL, it actually may not pass the full validation check for BCO because it doesn't contain certain information. So you can see actually for here, because I just imported this from DNAnexus, it doesn't contain all of the values. If I click on like the IO domain, you can see that for the input subdomain, it doesn't have a value. And so it's giving me this red in order to indicate that there's a problem. You can go through and you can update these. And so if I scroll down, I can take like, input subdomain is empty. Okay, according to the BCO schema, this is a problem. If I click on this, I can actually, so if I was to go back to the input subdomain, I can actually go and update that. If I go to IO, we'll go to input subdomain, we'll add a row, we'll give this
yeah, we're going to have to update that nav too, Sam, so that you can link straight to the object from the error page. But
yep,
we'll go back and do that.
Yep. So if I enter some values, you can see I've got a line in here. If I go back up now for input subdomain, it has a 1 because there is a line of information that I just entered in there. And so now if I went back to review, it will rerun. And now if I expand IO domain, you can see that for input subdomain, okay, we'll scroll down to it. You can see that for IO domain, the output domain is still empty. I didn't enter anything for there, but it no longer gives me a failure message for the input subdomain being empty. And just to reiterate, if I was to go back to here in IO domain, if I went to the output subdomain, add a row, we'll say BAM, this is BAM file, this is, file.txt, give it some information. Then now, when I go back to my review page, it will do another check, and it will say for IO domain, I think I left a value blank. Output subdomain, we'll give it an actual date time. Give it a checksum of 1, 2, 3. This is all example information. So now when I go to review, you can see the IO domain turns blue. And so this is a great way if you are setting up a BCO coming from other data objects, you're coming from a WDL file, you're coming from CWL files, you're coming from a DNAnexus workflow, to go through and validate this in order to make sure that you have all the proper fields in order to have this be a complete acceptable BCO. So once you've gone through this and you've gotten this to the point where you are happy with your BCO, you're probably going to want to save it. You don't want this to just be something that's in memory. This is great for editing. This is great for doing on-the-fly tweaks to it, but you're going to want to be able to export this. And so that's why we have this export tab. And there's a number of different options here. The first option, as Omar showed, is you can export this to local. So if I say this is a great workshop BCO amazing, and call it something like this, give it whatever name we choose, and then I can say download, and this will download onto my local machine.
Great.
So that's great.
BCO
That way
name.
you can.
Good BCO
Thank
name.
you. Yes, I'm very, very creative with my names. And so this way you can save this onto your local machine, and then you can always do this as an intermediate step where then if I say, okay, now I want to start over or I'm coming back the next day, I can go load up a BCO. I can choose, for example, that file that I just created, which is in my downloads. You can see here it is great working of Workshop BCO amazing. I can open this one. And if I click on update, this would copy it over everything else and duplicate stuff. So instead, I'll say load. And what it does is it cleared the previous BCO information that's in here, and it loaded this saved intermediate that I just put in. So now if I go to parametric, you can see all of my values are still there. If I go to provenance, you can see it didn't duplicate this time, it just loaded this one in. So this is really great if you're putting things out to local. But one of the big things about BioComputeNexus is we want it to be integrated with DNAnexus. We want this to be able to have this seamless interaction with your cloud environment. So another option under export is to actually export this back to DNAnexus. And so in here, I can put in my same file name that I happen to save. I can choose which project I want to export this to. So again, this uses all the credentials for that API token. Right now, because I only gave my API token access to this one project, that's where it's going to be exported. But if I was doing this on my local and I created an API token that has full permissions across all of my DNAnexus projects, then I could always export this to a different DNAnexus project. This could be really great if you have one project on DNAnexus, which is your scratch area, your place where you tinker with workflows, you build some new tools, you put workflows together, run them with test data, and you really make sure that they are functioning properly. And then after you have a workflow that functions properly, you might want to export that into a project where you're working with real data and you're working with collaborators. So this way you could load in a BCO or a DNAnexus workflow from your Scratch project, confirm everything is valid, it's a proper BCO, and then you could export it to a separate project where you're working with reviewers. So I'm just going to export to the same project because this is a demo and we don't need to show super complex stuff. So then when I say upload to DNAnexus, it will actually send this up to the DNAnexus platform and says file upload successful. And remember, the name for this is Great Workshop BCO Amazing. So if I go back to my DNAnexus project, and in here, if I go all the way up to the top, I think because this is sorted by created date, if I refresh this page, what we'll find is there's going to be, hey, there it is. Once this finishes refreshing, we'll see that that BCO now exists on DNAnexus. And so if you choose, you can then load this into DNAnexus using our DX compiler in order to set this up as a workflow. So you can actually use this as a way to pass around workflows. And you could use this as a way to, if you build a workflow, download it into the BCOnexus, make the changes in order to make this a valid BCO, add your contributor information, add your provenance information, and then send it off to another project. And when I click on this, I can actually load it up, and we'll see that this is now the full BCO JSON object. So in here is all the information. Here is that provenance data that we loaded in that was not originally part of this workflow, and now it's included in here. So this is a great way for you to be able to add that information to a DNAnexus workflow and then submit it back to the platform. And then finally, the third option is, as we talked about earlier this morning in this workshop, there are BCO repositories, and these are places where these BCOs can be made public and they can be shared, and GWU has done a great job of setting those up. And so this tool, you can actually give it the URL of a public BCO database, and then you give it your prefix, owner group, and your user token, and you can export your BCOs into one of these public BCO DBs as well. So this would be, probably not the intermediate. This would be after you've confirmed that everything works. But once you have your final BCO, you have gone through and you've used this BCOnexus in order to review and check changes, in order to say like, hey, let me go through and double check all the fields. Let me use the review function in order to make sure that all of the required fields are completed and there's no empty fields in here. Let me validate the BCO schema. Then you can use this in order to export directly up to the BCO DB. So this way you don't have to go through like, I'm going to download it onto my local machine, then I'm going to navigate to the BCO DB, then I'm going to click upload, and I'm going to transfer it back and forth. You can do it straight from the application. And so I think this covers most of the use cases. I'll also note that the goal here is really, it's try and be user-friendly. So as Omar showed, with each of these domains, we pull in all the schema descriptions and all the information. So you can click on a little eye next to each of these in order to get the description for each of these domains. Then if you click into a domain and you're like, okay, I see that this requires, software prerequisites. What exactly do they mean by that? I can actually get the IEEE 2791 description of that pulled directly from the schema. So anytime the schema updates, so will these descriptions. I can even see, for checksum, here is the description of what it is. So this way, if I am curious about what to enter for any of these fields, I can always click on them in order to see what the definition of them is. And so the tool here, there are a couple limitations. I wouldn't necessarily use this in order to build a BCO entirely from scratch. And we don't let you directly edit the JSON, right? If you wanted to make changes to the actual JSON, and you really want to roll up your sleeves and you want to type it out yourself in a text editor, this is not the tool for you. But with this, what you would do is you would export it, and then you could load up the local file in your editor in order to make any additions there. But this does validate the schema, this does load everything in, and this allows for that layering and merging in order to combine different BCOs with DNAnexus workflows, with WDL files, with CWL files, in order to create an output BCO that you know is validated. I think, Omar, that covers pretty much everything for the BCO Nexus. I know we have a bit of time left, so we can take some questions, or if people want to see any part of this again. I know sometimes with WebEx, it tends to be not the smoothest when it's doing screen sharing and video sharing, and it's handling audio as well. So if anything wasn't clear, people can throw that into the comments, and I am happy to go over it again.
So just to let folks know, this will be released as open source software. This has not gone through the maturity tests that our colleagues from Seven Bridges BCO packages have. They've been around for some time. So I expect that we're going to probably have some polish that we're going to add to this. But any comments, any contributions, I think this is all, Jonathan, you can correct me if I'm wrong, but I think this will be published by GWU at some GitHub somewhere, but we're not quite there yet.
Yeah, that's right. So I think we can include a place for it on our portal website. I think Hadley was talking about that. We can include a card for it as well there too. Yeah.
Yeah, if you were going to publish the raw code, then we would love to fork a repository in the BioCompute organization on GitHub. Or if you just wanted to, we also have BioCompute Docker space, which hasn't been utilized very much. There are a few things there, but we could start with your Docker image there if you'd like to do that too. But,
sure,
we can
the flagship Docker image. Yeah, I think that sounds great. I really would love to get the source code out there so that people can, enhance this and make it better and stuff. That's how things get better. I feel pretty good about this, just because it's a different approach and it's very schema driven. And as Sam said, I think this is more of a surgical tool than a start from the bottom and type in your BCO from scratch. But I found it to be very useful to combine and layer, and again, to be able to pull in things from different sources and export to different destinations. So we'll kick the tires on us once we get it out there, and please, we'll make sure there's a path for input and comments. We're probably going to do another little round of user acceptance testing and usability updates, but it's working pretty darn well.
Yep. When we release this, I'll also mention we'll also put out a full user guide for this. So everything you've seen in the workshop will be covered in here. How to load, how to set it up and install it, how to load in files, how to update, the difference between loading versus updating, resetting, deleting rows, making changes, reviewing, and exporting. We'll cover all that. I know for me, I go to these workshops and I'm like, this is fascinating stuff. And then 3 days later, I'm like, I remember they talked about it and it was really cool and I don't remember the details. So we'll make sure that we release that along with it when we put this out. So there will be a guide. And yeah, what I really like about it is I started off my bioinformatics career where I had to load up text files. I had to do everything in a text editor, and there was no way to really visualize the complete workflow that I was working on. And so I think with the BCONexus tool, this really opens up a whole new way to view these BCO files and to really see this idea of different levels and different domains where you can drill down from, the very top level down into different domains and then into the different subdomains within here. And this is really useful in order to be able to visualize the whole workflow and see how each of the different parts comes together instead of trying to just scroll up and down in a text file. So yeah, if you have any other questions, my name again is Sam Westrike and my colleague Omar Sarang. Both of us are at DNAnexus. You can easily find our contact information, I think, all over the web. please feel free to reach out to us if you have any questions, or if you're like, this looks amazing, I want to get my hands on it right now, and we can work with you.
Yeah, I like your description of it as a surgical tool. It sounds like it's sort of, a nice interface between the sort of nuts and bolts of the workflow and then the kind of BCO reporting aspect of it, because it's essentially, most of the heavy lifting seems to have already been done. And so you use it sort of as a surgical tool to kind of get in there and make the tweaks that you want and so forth, and make a high quality BCO report out of it. A fair way of describing it.
Yeah, I think the merging is also really important. It's a great way to build a set of BCO snippets, assets, and to be able to use those in a repository to combine them as you need them. We do anticipate that there will be a lot of projects where it will have a similar set of provenance. It'll have similar, there will be certain domains that'll be quite repeatable, and we're hoping that this will help lead to some templating. We're thinking about getting an editor in it, but as Sam pointed out, it's really easy to get the JSON out of it and then use your IDE or whatever editor that's giving you pretty print, of the JSON. So we didn't really want to duplicate that functionality in there. But I wouldn't mind maybe getting a JSON at least viewer in it, so you didn't have to leave the tool to at least see the JSON. So those are some things we might consider. As far as it being, the only thing I wouldn't want to use it for is, again, to sit down and try to build the BCO from scratch. It's not really a BCO workflow tool. It's really, I think it's more to do, again, with how you would work with multiple pieces of BCOs and just having that sort of in-memory tool. Again, surgical. It is, you're sitting right in there, being able to dive right into any key you want, make the mods, craft the in-memory image to your liking.
Yep.
Right.
And it's very lightweight. Once you have the Docker image on your local machine, it takes literally 15 seconds to go from nothing to having it up and running and having data loaded into it. And so the idea here is that instead of loading up your entire IDE environment where you're going to be doing in-depth editing, if you just want to do some checks of a BCO, if you just want to go through and be able to explore it at this interactive fashion and confirm that certain values are in there, check version information, check to make sure that it properly captures all the information, check the validity, this is a really great, really fast way to be able to do so. We want to have it be very lightweight, very agile, and so it's just something where this can be a great tool that is able to fit into your BCO workflow, whatever steps you might be at.
Mm-hmm. I like that way of describing it a lot, and that's, as you said, it's not meant for like building it from the ground up, but that's not really what it's meant to do, right? It's meant to interface with your workflows on DNAnexus, and so it's kind of neat that you can pull the workflow into DNAnexus from the BCO. And so I guess assuming all those tools exist on DNAnexus, then once you pull that into a DNAnexus workflow, I guess you could rerun that workflow. Is that correct?
Yeah, and you can also, on DNAnexus, we have a tool called DXCompiler that will take WDL, CWL, or BCO and will actually build a new workflow from it. So this could even be used for...
Actually, I checked with our developers. The DXCompiler is integrated into the tool. We just have to figure out exactly how it works. But the idea is that the BCO Nexus has DXCompiler built in and will be able to take WDL and actually instantiate a DNAnexus platform workflow. Sam and I just could not figure out how to get it working over the weekend. So we'll get that going. Yeah.
Yep. So you saw in this demo that I was able to export the BCO and it appears on a file as a file on DNAnexus. And so right now you can grab it as that file and you could use the DXCompiler in order to build that into a new DNAnexus workflow. And we're going to have that be, as Omar mentioned, a one-stop click where actually from the BCO Nexus tool, if you take an existing workflow, you add additional information, then you'll actually be able to rebuild that as a new executable workflow on DNAnexus. It won't overwrite the old one. The old workflow will still be there, so we still maintain all of that provenance and all that trackability, but you'll have a new one. So this is great where if you are updating your workflow either just with relevant BCO information like provenance domain contributors, or if you're adding on new tools and you're merging multiple steps together, to be able to then, assuming that everything is properly connected and aligned, to then build that to say, hey, I have 2 workflows on DNAnexus. I'm going to pull them both into this BCOnexus editor. I'm going to merge them. I'm going to combine them into one big Papa workflow that is able to handle everything. And then I'm going to build that back on DNAnexus. And now I have my big merge combined Papa workflow on DNAnexus as well.
Mm-hmm.
I do also want to mention, I did get one question in the chat, which is that if a DNAnexus workflow already has some provenance items, for example, and another BCO is imported and layered with additional provenance information, what happens in the editor? What's BCOnexus going to show? And that is a really great question. We don't want to be destructive when you're loading data in, so we'll actually show both of the provenance information in the BCOnexus editor. If I was to, for example, load the same file twice, I'll actually get 2 entries for each of the BCOnexus, each of the provenance items and each of the other items. And then in the editor, what I can go through is I can actually go through it and I can delete the rows that I don't want. So rather than us selecting for you and saying, we're going to take, the latest by date, or we're going to take the one that is of certain values, we're going to have this one be default, we'll actually load all of the information from both. And then you can go through when you're reviewing and delete out the rows that you don't want.
The one thing I did want to point out in terms of regulatory, since this is definitely intended to be support regulatory interactions with FDA, by using the DNAnexus platform as a repository for your BCOs and your projects, you also end up inheriting all of the immutability, chain of provenance tracking, and other features that allow this to work in a GCP environment or in a FedRAMP authorized environment. So that is another reason it's good to be going in and out of the platform. Precision FDA has similar attributes in terms of data immutability and provenance. So this will fit well within a regulatory environment. The other thing too is this will run just fine on Precision FDA. You could stand up a Precision FDA workstation and simply run the Docker image, and then you could manipulate all of the BCO stuff in a completely regulated environment. So I just wanted to point that out.
Yep.
Yeah, very cool. I will also say that I really kind of liked the snippets idea that you were talking about, and sort of either hinting at or explicitly mentioning this idea of templating, because that was, I think, a very powerful way to use it. As I think Sam said, if you have, I know that I'm going to use this piece, and this piece over and over again, and can just kind of like pull those in and build your BCO around that. That's kind of something we've been talking a little bit about in the BCO community for a while now, this idea of like building a template of the things that are, reused heavily. And then you can build a BCO around that. So I thought that was a really, really nice example of kind of leveraging some of the power of a BCO like this.
Yep. And then if you have a template where it's 95% correct, but you're like, oh, wait, I need to update that one field, you can always load that template in. And then in the BCOnexus editor, you can actually just go to that field, flip that, and make the change there. And you could either use this to quickly update your templates, or if you're like, I just need to make that change for this one particular BCO that I'm exporting, just make it in the editor and then export. Mm-hmm. So again, very lightweight way to make those last minute changes without having to necessarily load up your IDE or a text editor and then scroll through for it.
Right. Okay, very cool. So I guess it's some demo use cases now. Is that what we're moving towards? Taking a look at the schedule.
I think we've largely covered that. I think actually we're a little ahead on time.
Yeah.
Oh, okay. Gotcha. Okay. Excuse me.
Actually, we're just, for our time slot, I think, oh, we were supposed to go to 11. You're right. No, I apologize. We're just too efficient.
I can talk
11. Oh, you're on Pacific Coast time, right? Oh, sorry.
We are
Sorry, indeed.
Pacific Coast.
Yeah.
versus, and then we can take a break if there is time till 2 o'clock. The template VCO versus run VCO. For those of you who are on the call, Omar and you all must have heard about this. So this whole idea about to create a template VCO, you need a researcher, scientist who is deciding. It's like writing a paper. So the idea is that they will have their input files, output files, test files, true positive, true negative, false positive, false negative. All of that can be recorded in the BCO. But once the template is done, just like in a wet lab, you can have a technician who is a bioinformatician can run it, or could be even a machine runs it again and again and again. So this whole idea separating of when a BCO is published and you should not be changing it again, but it can still be run many, many times, is something that we had talked about even in the early days, like 10 years ago. We were talking about how important it is not play around with the workflow once something is in production. So any comments, Omar, and ideas about based on your user groups and how that is done, where somebody decides this is how we're going to run the analysis, and then the parameters and the tools and the software is kind of fixed, and then you move and run it again and again. Only the input and output files would change in some cases. That's it. But even then, the error domain will tell what range is allowed in that change, or it will throw out an error. So that's the whole idea about how these things can tie together.
Yeah, we hadn't taken it any further than this. The concept of the layering really came in when we realized that this was sort of an in-memory editor, and it was really the addition of the update button that sort of led to this. We've realized that, gosh, there's all these different pieces. It'd be nice to combine them. So I'm afraid we haven't taken it any further than enabling it, but I'm hoping that, as Jonathan pointed out, this will actually help support the concept of templating and the ability to build from multiple pieces. So I think, I mean, I could see in our own shop, we would end up with just a repository of pieces that I know we'll use. In terms of a regulatory environment, it just makes complete sense to have these pre-built, validated parts, especially if you're facing a regulator. And I could see that happening facing the FDA. And at some point, we expect that BioComputeNexus will integrate with precision FDA workflows as well. And then I think that'll kind of come full circle in terms of really having this regulatory grade thing. And the FDA is constantly thinking about templates, Raja, for exactly that, for how to do a specific regulatory process, whether it's an NGS or a microbiome population, whatever it is, whatever the BCO pipeline is. It'd be great to have the FDA able to ingest it, work with it, be flexible with it.
Yep. I'll also mention that from a specific implementation standpoint, I think the best way to do that would be to actually make sure that whatever standard workflows you're working with will be data objects that you'd maintain in one DNAnexus project. And that way you can always load those into the editor if you're going to make changes or customizations, but you would always maintain one project on DNAnexus that contains your starting default workflows, and those would always be the templates that you'd build from. And so you could always load those in, you could make whatever customizations you want, and then publish into the specific DNAnexus project where you're going to be doing that particular analysis. I do this right now. I have some microbiome workflows because my background is microbiome. And so I have some standard workflows that are built and they stay in one DNAnexus project, which is just my workflows project. And so I keep them there. And then when I have a particular use case come up, I'll actually copy it out of there. I'll make whatever tweaks I need for that particular analysis, and then I'll put it in the project that's specifically for that analysis. And so that way I always maintain this provenance where I can show that this came from this original default standard workflow, and then I can have this customized version. I can always compare the two in order to be able to see what changes were made and how the customized version differs from that original. And so the point of this
BCO make a transition to another room here. I apologize. I'm being booted out, so I'll drop it off for a second.
But yep, so the goal here really is then BioComputeNexus editor would be a great way to either review to see what changes were made, or to be the thing that is used in order to pull that standard workflow, make those customizations, whether that's done by making direct changes to it or by layering, and then handle the export. I hope that made sense. I hope that's clear.
No,
that's great. It takes a little time getting used to this idea of unlimited cloud environments with as many environments and as many projects as you choose to set up. And so I think
Really
it
does.
opens
Yeah,
up.
yeah,
Yeah.
I mean,
Definitely does. I think that this idea of templating is a really interesting one and has a lot of potential and may, at some point even sort of extend out beyond regulatory when we're thinking about, or extend beyond FDA when we're thinking about regulatory. It could even potentially sort of be like a CAP-CLIA type of a thing where you've got a particular, clinical test that might be, the template has been sort of cleared for a specific set of data and a specific kind of data, so to speak. That's maybe a bigger conversation, but one that's sort of, at least in the back of my mind.
Yeah, I think it's worth discussing, and I think definitely there could be a way that we might look at exploring in the future in order to actually be able to have those templates be saved as something other than just a file object like any other. And it might be useful to actually be able to choose, like, I want to import a specific BCO or a specific subset of a BCO as a template. And then you could have that saved, and that could be pulled up at any time and overlaid onto your working BCO where you're making various changes.
Mm-hmm.
Yeah, the other option would be to potentially get a viewer built into the platform so that if you open the BCO object file on the platform, it would open up BioComputeNexus. So that's another option that we could consider as well.
Yep. The default viewer right now is just going to be a plain text viewer,
Yep.
which is useful if you just wanted to do a really quick check to say, like, oh, let me check which version I'm looking at. But if you are doing something where you want to really roll up your sleeves and dive in, then being able to load up the BioComputeNexus editor, even without having Docker or anything going on your computer, just load it up completely in the browser, I think would be an awesome addition.
Yeah, that'd be really great. It'd be a nice way to kind of visualize it too, and kind of get that intuitive component added to it. As you say, not having to drill into the long text file.
Yeah, exactly.
so we are a little bit early, but Dennis is here. Jonathan and Dennis, is it okay if we continue with Dennis? Then everybody who is on the call will get to also leave a little bit early, or we can chat at the end, continue with the discussion.
Yeah, that's okay with me if it's okay with you, Dennis. Oh, you're muted though. Are you? Oh, here we go. How about I make you a presenter? That'll give you more.
I did it.
More. There we go. Okay, great.
I said absolutely yes.
Okay, terrific.
I just have to organize my screens a little bit, but I think I'm ready to go. So, hello everyone. The BCO working group is one of my favorite groups to work with. Raja at GW, Vahan was very involved, everyone at GW. DNAnexus has been an unbelievable contributor over the last year. And I'm like, wow, that's a cool feature. How'd you come up with it? So I think what's great about working as a group is you inspire each other to kind of move forward. Let me just share my screen and let me just make sure it's going to go to the right screen. It does. Great. So sharing. And it's going to be screen number 1. Okay, great. And I'm going to actually switch the camera and maybe you can see me while I speak a little better. Great. And popping up the center view. So hello, everyone. I want to spend some time telling you about our BCO work. And my agenda for today is to first talk about our motivation, like what are we thinking about? And that really informed how we approached building our BCO app. I want to talk a little bit about the platform perspective. Similar to DNAnexus, we do have a standalone app. We also think because we're platform-based that it's really on us to think through what are the most important concepts for enabling a platform. The next part we want to talk about is really just demos, but I broke it down to different areas that I could talk about, and I can expand or contract or go back to questions. But at first, I'll talk a little bit about our BCO app, its availability, the examples we developed and their availability, particularly once that is done, I then want to talk about the different ways we can create a BCO from text, from a workflow or a task. And then lastly, I have a section for advanced topics that I'll probably go through really quickly. Is one of the use cases we're seeing a lot of is a need and desire to execute BCOs. And in our case, we're kind of biased towards CWL. So we see a lot of use cases where people want to use a workflow on our platform and then locally. So I want to talk a little bit about how we do that. And then lastly, as part of this last year, our discussions, we started talking about what best practices might look like. And particularly, or just recently, I had the ability to meet with some people who work with the FDA. And I have my dog, if you hear him, doesn't like the doorbell. That I've been thinking about, so I thought I would just introduce it. So motivation. So this is the early paper. I think this is Vahan's early paper. And really the concept is, how do we bring experimental rigor to bioinformatics? Specifically, the challenge here is, how do we maintain the context of the parameter set? You know, some parameter sets work well for a particular data set and applications, and some just don't. And so how do we document that? Now, the idea, I'm not going to talk about the content of a BCO because that's already been discussed, but what I do want to talk about is there's a wide range of potential stakeholders. And, you know, although we're really thinking about regulatory review, there's also many other applications that might be able to use BCOs. So I think it's important to think about it as we start to build tools. And then one of my favorite concepts, and I remember sitting in a BCO planning meeting where this idea of an umbrella of standards could be used with the BCO. So the BCO could be an overarching set of standards integrated to make it easier to collect information. And one example Jonathan talked about is using research objects, for example. Now, the BCO itself is actually really simple. And at its core, it's text. And because of that, I think it's really important to think through the process of having a text document, in this case, a JSON. The real question is, how do we make it so that it's easy to use within the operational setting? And I believe we need tools to do that. And we've already seen a couple of tools, and there's probably a handful more that weren't discussed today. I tend to think more forward in that, what is the entire scope that we might want to think about? And so this is kind of the framework that we think about BCOs. On the left side, what use cases do we want to support? What are the basic inputs? You know, we have an architecture for our BCO app. We have an open source component, but we see us having also an integrated component. And I won't talk a lot about that, but I would say that we do have both an open source and an integrated component. I'm thinking we're going to need add-ons for specific applications: image processing, machine learning, deep learning, clinical trials. We do have libraries for supporting all the basic functionality. And then lastly, we have a variety of outputs that we can generate with our BCO app. And the latest output is writing to the BCO database. Okay, so I'm going to shift a little bit. So let me talk a little bit about how we're thinking about a platform. So we were fortunate to do our BCO work right from the beginning on our Cancer Genomics Cloud. It's an NCI-funded platform, and the requirement of working on the platform is that everything has to be open source, which is really great for collaborating on standards. Over the last few years, the CGC has expanded substantially. If you look in the lower left-hand corner, there's now 3 petabytes of data, over 762 80,000 user-centered created workflows. I got to find out about those. That's pretty impressive. It's impressive to me. You know, we work within the NCI research environment. So we're one node, but we've been helping with building the infrastructure that will allow cancer researchers and in fact, NIH researchers with some of our other publicly funded platforms to do collaborative research. I mentioned quickly the amount of data. It's been really impressive how the NCI has really pushed to making data available. So we had our first data drop about 2015 with TCGA. And now with in 2021, like I'm not going to go through them, but you can see just many well-known studies are now available, or the data for these studies are available. There's something I decided to own right from the start, and that's that we're CWL centric. And I will agree that it's not, well, but in thinking about how we build our BCO app, we really thought about how can we use the structure within the common workflow language to help develop a BCO. Like DNAnexus, WDL is really popular and may even be more popular than CWL at this point. So how we think about how we bring in structured language, I think, is the really important concept. Now that we've done it once, it should be straightforward to expand to another language. There's a lot of ideas here that I won't go into for making tools reproducible, which is really a focus of how we think. I'm going to jump over this, but the really important part here in the platform view is how do we combine probably 2 or 3 things. The first is an open source view. How do we use expanded features within the platform to make BCO generation easier? And then just based on our NCI and our NIH framework, we really want to make our work as reproducible as possible. And we see BCOs having a role there. Now, despite all the technical work my team does and I tend to do, I always seem to go back to what is the simplest implementation. And our simplest implementation is this Word document that basically outlines a BCO. And what I like about this document is you could put all the information here, you can interact with it, and this was really helpful. We did this exercise a few times before building our BCO app, and I actually think it has a role now, even with the BCO app here. There's an opportunity to collect information distributedly and then to add it later. Especially if you're concerned about large text, you can have a grammar checker. There's lots of reasons why this still, I believe, has a role. Core to our approach is parsing the CWL. For those who haven't used CWL, Common Workflow Language is basically a bioinformatics language that allows you to link inputs, tools, and outputs into a graph-like structure. And our platform is built on being able to execute on this graph efficiently on the cloud. So the BCO app availability. So a great place to start is our BCO app manuscript. It was published earlier in the year, and it's the version is linked with a previous Precision FDA challenge. And so all the code examples, a container, are all freely available. We do have an update coming. We found out recently that Git changed their security process, so we want to just update the Git writing functionality, which I'll mention later. And once that is updated, we'll have a new release soon. The other thing that we've done is we've made the BCO app available as a custom front end. So it's basically when you start on the Cancer Genomics Cloud or the CGC, it's just another option. Right now, this option is hidden to select users, but we see a role in rolling out the app here. And what's nice about that is that you would have direct access to the workflows, the data, and the tasks. You wouldn't have to use an API to jump in like we're doing now. So I'm going to do a BCO demonstration tool. I'm thinking I'm going to go really fast. I don't know that I need an hour and a half, but I will stop for questions. Let's see, how do I want to do this? So first, what I want to do is orient you, and maybe what I'll do is go through the slides first with one example, and then I'll use the tool to show you what it looks like live. And I have a bunch of examples. So the people on my team were really great in the last week or so. We put together a project. This is the CGC interface, and we're looking at a specific project. This project is called BCO CWL examples, and we put together a handful of examples, and they put some of my favorites. So there's examples for RNA-seq or GATK, so kind of the standard processing. We have examples from a consortium. I help lead the PDXNet consortium, for example. And then we also add a neoantigen pipeline. This is the neopeptide analysis. And the idea is to have examples that will resonate with a wide variety of users. And I just put the references here. Our thought is that we will make this project publicly available so that anyone can look at these examples and then use the BCO app to actually try them. And this might be a good starting point for learning about BCOs. Okay, let me do, I think it would be great if I do one by slides. And then I'll do it live so you can get a sense of how it works. So this is the BCO splash screen. So this is what happens when you start. I'm very proud of my team. The app came in first in the app competition a few years ago. And you know, when you have a team, they're the ones staying up late, fixing the code, finding the bugs, and they all jumped in to make that happen. So I really want to thank them, and I have their picture at the end. These three buttons I think is important and helps to illustrate how we think about creating a BCO. The first is just a text composer. It's equivalent or close to the editors that have been spoken about earlier in the day. So it just allows you to edit fields in a BCO. It's our first implementation. We then have a CWL composer, so you can pull any CWL and it will populate as many fields as it can find, and then you can edit the fields afterwards. And then we have a platform composer, and this allows you to use the Seven Bridges API to connect to the CGC. And I believe the app is set up for any of our projects at the time. I think it's 5 different platforms or so. And what's nice about that is you can also select a task. And so then you can have the inputs and outputs and some of the description information. And then we have, I believe, a really good help section. So once you get started, and so what I'm showing here is the platform composer. And the steps are numerated 1 through 6. And so our app kind of walks you through. The first part is just to figure out what platform you're going to use. So we're going to start with the Cancer Genomics Cloud. You know, we need some tokens, and the fields populate as you select things. So this is just blown up a little bigger. So if you choose a project, Sonar is a person on my team, I can then select a particular workflow to work on. Once you do that, it then goes to step 2, which allows you to set the provenance information. The green are auto selected or are filled automatically. And then we have some fields down here at the bottom that you can change the date as appropriate. it's a long, when we look at the real app, you'll see that there's a long list. So I'm just cutting off for demonstration purposes. One of my favorite features on our BCO app is the ability to scroll in and look at the CWL. So you can see the apps that are being used, what are the inputs, and then what are the outputs. We have the provenance information. So this is the provenance domain. These are the fields that are auto generated. So we're now on step 3, which is the execution domain. Similar, it's a similar concept, but not as thoroughly developed as my DNAnexus colleagues. Right now, we're using the CWL. We're listing it as a script, and this is what's going to allow us to make this executable later. Great additions, which we don't have, would be to have WDL documents supported also. So this is just blown up so you can see that a little bit more. This is basically our CWL text file. It could be quite large, but we're finding that we can embed it in the BCO and work with it well. So here's an example from the description domain. And if you look down here, this is one of the advantages of using CWL is the actual tools that are being used are pulled directly from the CWL, and the description of the tools and the tool versions are automatically pulled in, or can be, is what I should say. So this is the same thing, but blown up a little bit more, so you can see the information of, I actually don't know what all the tools do. That's interesting, but I'll move on. So we're now going to the input and output domain. Because I pulled in the CWL, there's no explicit input and output. But if we had a task that was successfully run, all the input and output will be shown. And I think I'll show that in a little bit. So we're now at step 6. We automatically assign a BCO ID, a unique ID. If you click on the Generate and Preview BCO, we will get a JSON. This text field starts empty, and then once you click on the button, it's generated. I'll show that later. And then the buttons on the bottom are basically different ways to export the BCO. So just blown up a little bit more, I'll show you this one when we go live, is the writing to the BioCompute object. It's the most recent addition to our app. When you click on that button, we basically get a dialog box that allows you to put in your BCO database token. You push on the button here, if it's successful, it says successful, code 200, and then we can open the database to see that it was successfully written. The last part before I believe I'll go to a live demo is we also have the entire standard on the tool. So you can basically click through and see the different parts of the standard. I often forget the domain names, so they're listed here across the top. And then once you click on the domain, you can see all the fields that are available. So let me stop here for a second. I can't see questions, so let's do this. I'm going to do some interactive demos. I'll do 2, I believe, and then I'll stop for questions, and then I'll summarize with a very short presentation, like on some advanced features that we're thinking about, but I'm not going to demo. So let me just move this over here, and hopefully nothing timed out. I'm just going to help. I'm going to try and help everyone get oriented a little bit. I have 3 tabs up here. In tab 1 is the Cancer Genomics Cloud. It's already on a project. Let me put it on the project that I just spoke about. This is the BCO CWL examples project. So basically here we have the text that I showed on the screen, some references, and since this is live, I can actually go to the where do I go? Data, project. What I'm going to go to examples. And then here I'm going to go to the apps in that example, just so you see I have a bunch of apps here. And then I'm going to pull them by the API. So we have a project and apps. This is our BCO tool. It times out pretty quickly, so I'm just going to reset it. I already showed the splash page. In a second, I'll go through and give you the overview, and then we'll pull in an example. And then lastly, this is the BioCompute database that was discussed earlier today. And I'll show that once we push, the new workflow will be pushed to the database. Okay, so let's go through our BCO lab. So this is our home screen. I'll just go through the menus quickly. Each of the three options or the buttons there are shown in the generator. We think about a generator as an input that produces a BCO output. And we can take text, we can take CWL, or we could work directly with the platform. We also have a few utilities. We do have a BCO browser where you can open it and take a look at it. I can't remember if we have read-write capability, but definitely read capability. We have a validator, so if you open a BCO, you can check if it's validated. We just did some work with GW to make sure our validator was consistent with theirs, and I believe that we now have an updated validator. And then lastly, this is the, I guess I can show you those because I'm not going to do them again, here is the interactive browser. Here is the validator, so you would select the BCO and it would say whether it was an appropriate BCO. We get some checksum information, and then we'll have some validation information relative to the schema. I look through this standard summary quite often in the beginning. After a while, you get used to the fields, but it's nice to have it right there. Okay, so what I'm going to go back to the home screen because that's the likely start place, and I'm going to do two examples. The first example is just going to use the CWL composer, and I'm going to take a CWL file off of my machine. And so what I do is I click on Browse. This is a CWL file. It's a PDX file, so this is part of the consortium, the PDXNet consortium. We have something like 16 workflows that people are using, and I think it's a really good documentation use case. Okay, so it's uploaded. You can see the progress bar. We're going to go to next. We see that this figure is generated on the fly, so it's generated from the CWL, and I'm just using my scroll bar, and you can see the names of the tools, or you can scroll back and then look at the edge. You can actually move it around. I find this really helpful to just double check and to make sure I understand what the workflow is doing. I'm going to just scroll down so you can see the rest of the page. So we have basically the provenance domain, the usability domain, and the execution domain here. And this allows you to edit the fields. Just for time, I'm not going to add text in all the fields. But we scroll down and we click next. This is the second domain. So, oh, it's the extension domain, I apologize. And then we have the execution and the parameter domain. This is where the CWL is written, and it's basically the file that we use to schedule execution on the cloud. We list our name. It's a 7 bridges common workflow language executor. That would expand if we used other languages. I'm not going to do this here, but basically we can add by clicking new and edit. This is one of the things that I wanted to show you, which is really a benefit of using a workflow language, whether it's CWL or WDL, is that there's so much information within there that it makes a great opportunity to reuse. And so these fields, so these are steps, pipeline steps. they're all taken directly from the CWL. It has the name of the tool, the description of the tool, if it's available, is posted. My team was very excited, by the way, when that started working. This isn't running a task, so there's no input or output information right now, but there could be if we ran a task, like a completed task. And then lastly, we're going to go to step 6, which is basically review and export. And what we're going to do is generate the BCO. It's pretty quick. This is the automatically generated unique ID that I discussed or I showed in my presentation. And let's do this because a major advance in this last year has been the BCO database. Let me write this generated BCO to the BCO database. So I click on this button here, and then I just have to look, let's see, and find I need my BCO developer token over there. So I'm going to copy it off screen. I'm going to paste it in this dialog box. And then I have to say who the owner of the BCO is, and we're doing BCO drafter. And let's see, will it work? We push, and yes, it's successful and it pushed. So I'm just going to close this here, and what I'm going to do is go to the BCO database, and it's likely whatever the last one is. I've obviously done a few of them in the last few days just to double check, but this is basically, if you look at the URL, the BioComputeObject.org, and this is how you connect to the database. It was already connected, but I believe it's been demoed already. All right, so I'm going to take a deep breath, and I'm going to start again. So that's the basic feature. And then I want to show you how it would work if you would connect to our platform. So what I'm going to do is go to home, and I'm just going to reset it because I always want things to make sure it's right from the start. We're going to do the platform composer. So what I want to do is connect to one of our platforms. You can see we have a few selected here or are available. They're drop-down menus. And what I'd like to do is let me get my CGC token. And you can see now the projects have been filled and the available CWL, and if there's a task available, it's listed here. I'm actually going to go to a different project. This is the project that we'll make publicly available, but a person on my team also created some. I'm going to do this one. I think this is the same set of PDX workflows like the one that I did earlier. And I'm going to pick the RNA-seq. And when you look at the task, you can actually see a bunch of different runs. I'm just going to pick the first one, and we're going to go next. The CWL is shown. Like I did before, you can scroll in, scroll out. And I actually want to show you just a couple of things here. So I'm going to go pretty fast because I want to show you like some of the things that you can do with a task that's different. So the first thing is you get a list of inputs and outputs, and these are all unique files. I haven't done them in a while, but these, someone on my team can put it in the chat if they're there. These are generally GUID, so they're URLs and they live forever as long as you have access to it. So we don't change our file names. And then let me go to next. So all the inputs and the outputs are preserved. I'm going to create a BCO. So I'm in the last step, step 6. Let's generate a BCO. And I showed you this part here, but let me just show you a couple of other things. One of the things you can do is export the JSON. And so let's see if I can open this. And now it opens with text pad, so you can just see that that was generated correctly. And then I believe it was Sonar or Nan on my team who generated this export. I'm really a fan of this export. And so this generates a BCO PDF. And if you scroll down, there's a table of contents, and then it's information for every field. One of the ways we see expanding that is we can imagine there might be exports for particular applications that could be customized, but it's a good way to kind of just look through very quickly if you don't have an interactive editor. Two things that I'm not going to demo today is one, you could upload to the Seven Bridges platform, so you could have the BCO put into the project that you generated from. This is now running on the internet, but it could be on my local machine. We do have a release that allows you to run on the platform, and you won't need to upload on the platform. It would be there automatically. And then lastly, a feature that was really well appreciated was writing to GitHub. However, that feature is not working right now. There's been an upgrade to GitHub security requirements, and so it's our last update before we make our next release, and we're planning to make that release open source as well. So with that said, I think I am going to move this over. And how long have I been speaking for? So like 40 minutes. Does anyone have questions about the app? I'll take a couple of questions. I can't see the questions right now, but if someone wanted to read, if there's no questions, that's fine. I just have a little bit more. Okay.
I can comment here. When you say add-ons for things like machine learning, I think this is a really thought-provoking idea since some workflows could have specific needs. I'm curious what form you're thinking that could take. Would it be things like extension domain schemas to extend it, for example, or something else? Like what do you have in mind for that?
Yeah, so let me do this. I'm going to discuss that at the end.
Sure, okay.
So let me go to the end. I think what I can do is do a few minutes to wrap up the presentation.
Okay.
And then I can take any question, I think
Sure.
is the way to do it. So I'm just going to scroll down to where I left off. I'm a fan of having slides just in case. And so I did this, but what I'll do is show you the features that aren't there, and then I'll skip over a slide and then do one more topic and wrap it up. Okay, so the other thing we do, and I went over it really quickly, we compute the checksum, which is really helpful in checking and validating. It comes up all the time when you share files, and if you just want to make sure that it's transferred correctly. I've actually gotten more requests for the checksum in recent years than I expected. This is an example of publishing a BCO to a Git page, and since I didn't demo the feature, I just wanted to show you. So we have a repository of Git pages that we've submitted to, and it allows you to submit automatically to GitHub. So these are BioCompute object examples, and if you click on the example, it's basically the JSON. This is very similar to some of the work the GW team has done, but it could be one way to share information. I showed this already, the PDF. So let me just give you one last conceptual concept, and then I'll wrap up my presentation. So this is an example from a computational cardiovascular project. The idea here was, so I'm still sharing, yes, great. It was a funded engagement from the European Union. It uses Seven Bridges graph. And the idea was, can you determine individualized treatment in a complex computational environment in a distributed fashion? I won't go through a lot of the details, but the idea was, could we share the CWL? And this is just a figure of one of the workflows that were used with another group, which would be the equivalent of our DOE, which was basically a large computational infrastructure. And the answer was yes, we could share the CWL, but it did take some tweaking to get it to run on the HPC. And so what we started working on, and this was done by my team member, Jeff, who's at another company right now, great guy. And he uses the CW script. I've pointed at this before. And he shows that you could use this information within a BCO to make it executable. And there's a Git page that explains how to do this. So basically, you can select the workflow, you could use our app, you could export it, and then use the BCO to run it. And he has a runner example. I don't believe we got to the point where we have a great interface, but he was able to show is using the CWL inside the BCO, you could then use an open source executor, Toil or CWL tool to run. And I think this is exciting personally. I think that, the first thing I want to do when I review a workflow is run it. And for anyone who's tried that, it could be minutes, days, months, impossible. So I like the idea of making it very easy for others to run workflows. So what did we learn developing a tool? My team tends to do prototypes, and the prototypes tend to be pretty good. And then what we do is work with our engineering teams to really operationalize it. So what we found is thinking about BCOs in multiple ways is really important. Paper, word processing, Confluent, Shiny App. Information is going to come from a variety of areas, so managing that is going to be important. And a tool won't be able to do everything. So giving really good, in my opinion, and so giving good guidance on the process of creating the BCO will be important. I'm a fan of CWL. It's a real great way to reuse the infrastructure. The idea behind it is reproducibility. So there's a lot of neat advantages, I believe, to using CWL. Let me just do, and so just to say where we're at, we're definitely thinking about how integrated the BCO app should be within a platform. There's this trade-off between interoperability and then advancing the platform. A test I would love to see is that it would be great if GW, DNAnexus, and 7bridges could share BCOs and use them effectively or write to the database. And we talked about doing that sometime in the future. Now, I only have 2 or 3 slides left, and the concept here is I believe we're beyond the standard at this point, at least the people who are working with BCOs all the time. The standard is how do you get the fields filled? That's what you do with the tool. And I want to point out, this great feature that DNAnexus put out. I believe it was Omar who demonstrated it. You could pull out different pieces of information from different sources and add it to the BCO. I think that that is a really important concept, and I want to add a little bit to that. I believe we want to go beyond filling in the fields and start talking about what are the pieces of information that is going to help regulatory review. So I'm talking about it because I think it's going to be a dialogue with the people reviewing workflows or submissions. So the concept that I really like thinking about is there's a characteristic. That characteristic has a risk. And then what good bioinformaticists do is they mitigate that risk somehow. It's this mitigation that I think is often missed when you document a workflow. So yes, you have all the tools, but saying, oh no, I reduce the parameter range to this because it works. That's the information that I think would be really great to have in a BCO. And so I'm going to expand that out, that concept a little bit. So this idea of characteristic risk and mitigation, and I think that there's an exchange risk, right? So how can we use a BCO to limit the exchange risk. And that risk might arise between two users exchanging a workflow, between organizations, or between regulatory submissions. And I'll just give one example. So if you have unfettered communication between two users, the worst that's going to happen is there's a short delay. And so maybe you can have better context in the description, whereas it could be quite complex between organizations. You may not be allowed to discuss the details of proprietary information. So I think really thinking through for each type of communication, characteristic and risk mitigation could provide some recommended standards for including information. Similarly, and this is why I skipped over your question, Jonathan, I had my team do two examples. One was a neoantigen workflow. So basically, how do you develop individualized treatment? My team also does a good amount of work in ML and AI. So we did process some ML classifiers. The interesting thing about an ML classifier, there's no information by design, right? Like it's one node, you have input, output, there's no context. And so really thinking about what information needs to be included in both of these cases. For the neoantigen is how do we make sure it's appropriate for a specific paper, a person? For the ML classifier, I'll just give you one example. We have a classifier, beautiful classifier. It will, based on RNA data, will say what tissue it likely is. Very great, except the training set has 30,000 columns. I still haven't figured out how to document that, but you get the idea here, right? These ML and AI tools are going to come out. We will have to review them. And I'll leave you with one concept before I switch to a different idea, is I was fortunate to be invited in an ethics and ML workshop sponsored by the NCI. And it's going to come down to people. Like we're going to have great tools, but it's going to come down to people who are thoughtful on what information is required, and then how do we deploy and check that these tools are working in the operational setting. All right. So sometimes you get lucky and you get excited. I had a mentor who is like, you have to meet John Wagner. He is a chief medical officer at Kineska Health. And I was looking at one of his presentations. It's an FDA public meeting, identification of concepts and terminology for multi-component biomarkers was the meeting. But in his presentation, he outlines the process, the qualification. And qualification is defined in his slides. It's actually referencing a bunch of NIH materials. This idea of a formal regulatory conclusion. Yes, we can use this thing for this indication. And he talks about the process of going from analytical validation, establishing performance characteristics, to clinical validation, establishing prediction capabilities. I did it backwards, but let's take a second and think about especially this part. I could imagine that there's a role for the BCO to collect this information on an ongoing basis. And think about many treatments start in the academic setting. And it might be 10, 20 years. Well, let's say not 20. It's going to be less than 10 years because we're going to be better, right? So in 3 to 4 years, we can collect all the information required in support of qualification. And I think things like that will make BCO helpful in the regulatory process. But this is my conjecture because I've never done regulatory review. So to just summarize, we really have a platform-enabled BioCompute object perspective. We work very heavily with open source tools. We believe there's a place for both. Really thinking about how we can use databases within our platform to supplement the BCO generation, we believe is going to be important. In the use cases, we really did multiple use cases because we just wanted to see, does it work? And one of the things that's a little challenging is CWL is not monolithic. there are different ways of adding information to the CWL. The more standard it is, the more information we would be able to pull out. This is just a point. The reason why I like doing a lot of examples, because I really want to see where it doesn't work. And our biggest challenge is that there's been multiple releases of CWL. And I think this is a perfect opportunity for industry, right? Who has the teams that can support the maintenance over time. Whereas my small team, it's hard for us to make sure it works for every version. Our engineering teams, we wouldn't even know the update happened because they would be on top of the updates. And then lastly, I feel like we've made so much progress with the BCO. Initially, I was in some of the early planning meetings where like, is this going to happen? And then it happened. And then there's clear penetration within the FDA. I think now that we're comfortable that the tools are coming, we really want to start talking about what are the best practices to really support regulatory reviewers. And so this is my current team, Sonar, Philip, Saul, who worked on this. And, I really want to acknowledge my previous team members on the left and right. Each made significant contributions. And then we collaborate with the GW team, and a lot of the funding comes from different programs at Seven Bridges. So I just wanted to make sure we made those acknowledges. Happy to do any questions and discussions. I'll find a way to make the slides available, but if you ping me or Philip, ping Philip because you'll more likely get a response quickly. We're happy to do demos or answer your questions one-on-one. So with that, I will stop sharing and I will turn. So let's see, I got to move this here. Happy to take questions, Jonathan.
Sure, yeah. Thanks a lot. That was great. And while these are coming in, I just want to comment that table did a great job of articulating, I think, some of the specific issues with workflow sharing. That was really nice to see, and I think also very thought-provoking. Okay, so you did address that question with the add-ons, and I guess to sort of comment on your answer, some of that, it sounds like sort of does come down to best practices, right? So if you have 30,000 columns, how do we go about representing that in the context of a BCO? Because those, I suppose, are technically parameters in the model. Does it make sense to have 30,000 parameters in a parametric domain? I don't know. Maybe we should just have a separate file to to document that, right? So things like that, I think, are probably worth keeping in mind. I think you're exactly right that a lot of this is now coming down to best practices to generate validated BCOs.
Can I just add one more piece to the machine learning?
Yeah.
I think it's really important. So even though there's 30,000, it's kind of a little inflammatory. I wanted to explain the scope of the issue.
Mhm.
But it turns out most machine learning methods will likely use 5 or 10. So maybe we make sure, make sure you do this, you follow these best practices. These are the parameters used primarily, and this is the link to the 30,000 with the definition that weren't used. Because I know I would want to know that, right? But it may not be necessary as the first pass. And then the second concept that we've talked about a number of times is we might have embedded BCOs. So it might be there's a link to the training data and how it was collected, how was it normalized. So there are things like that we can do. And as a person who has developed tools for a number of years, changing input and changing standards is kind of a not fun activity.
Mhm.
So, really working with the standard as it is and figuring how to adapt the standard to tackle these real world problems or issues is the way to go, I believe.
Yep. Yeah, and I
was a
think fleshing out
really. Oh, sorry. Go ahead.
I was just going to say, very much agree, and I think fleshing out the best practices in a regulatory setting is going to be really important near future work, along those lines. But I will hold the other stuff. So go ahead, Raja.
Yeah. So collecting input and best practices is a document that we already have started. And the question always is this: best practices versus the standard. We don't envision the standard to change continuously all the time, but if needed in the future or a certain period of time, maybe years, certain things can be added, and maybe some of the best practices can make it to the standard in a future iteration. But we definitely want to make sure that the standard is not changing a lot so that tool developers can develop their tools and so on. There's one item which was not discussed by Galaxy, DNAnexus, or 7bridges, but I wanted to bring this up because I'm sure we have a wide variety of participants today. It's the cost. So the cost, cloud cost. So we did get a NSF award several years back via Internet 2. We were a sub on that one, where we worked on using BioCompute objects to predict the cost. So I have a BioCompute object, so I want to run this on similar type of data. How much would it cost me? And we got some really interesting and nice results. But of course, that project ended and we didn't have everything takes effort and time, but I still am interested in that because many times, I'm in a university, I'm in the biochemistry department actually. Most of the time when I talk to my colleagues, they are worried about cost, cloud cost, and it's not cheap, and predicting them is really hard. So do you see any, based on some of your slides, it looks like that's something maybe you have thought about, or what do you think about that?
Sure. Is it okay if I share my screen?
Mm-hmm.
Okay, let's share my screen. Let's see, what screen is that? Screen 1 still. Share. Can you see this portal page?
Yes.
Okay.
Yeah.
So I literally got an email today asking me to meet with the engineering teams to talk about predicting cloud costs. It's an ongoing discussion with the NIH. And let me tell you how my team has looked at this. So this is the PDXNet portal. It's a program that I run the 7bridges part. I just want to orient you a little bit. Let's see, where are the workflows? We have 16 workflows. I think there's only 12 listed here. I talked about them. It's to whole exome, RNA-seq. It's what you would expect. And the question is, I'm writing a grant. How much do I put in for cloud costs? And so what Jeff on my team, many of you on the call know him, and Sonar worked on, and Sonar eventually got the working model, is based on the archived runs. We can pick the workflow we want to predict. And then we can just basically say how many runs we want to do. If we have 5,000 samples. So let's say it's, I don't know, 1,000. And the file size is 10 megs. I don't know what the units are, so I apologize for that. But if it calculates, we could then calculate what the range of cost it would be to run this workflow on 1,000 samples, and the average size, I think it's 10 meg are the units. And so on the right, we see the cost. So how did we do that? The way we did that was by using the archived runs. I'm going to stop sharing. I believe Sonar used a random forest to do the computation. So we do have an upper bound and a lower bound. Jeff used linear models. That didn't come out as well. So to answer your question, yes, we've thought about it. We've had a lot of luck with using random forests for runs that we know. But let me tell you something, it's in my head, but I haven't done, is predicting costs should be a linear model. And so one of the things I'm thinking about is how could we use our 7bridges archived runs and a list of tools to make a generalized workflow predictor? Because sometimes you know what the workflow is, but you have no runs. And so that's the problem I'm starting to think about. Was that helpful?
So one of the things that I'd worked with Nicola a little bit on, Galaxy EU actually has an extension where they will tell you how much computational resources you've used, or that kind of thing, and it's used as a AWS cost estimate, and it's an estimate, but it's a estimate of what you've spent, not what you will spend to do something. So I think what you're coming at it from, Dennis, is like the other side of it, where we've already kind of played around with it a little bit on the back end, saying like at least having a record of what you've spent. And maybe like if we could meet somewhere in the middle, that would be great. I mean, I think that what I was looking at doing with BioCompute Objects in particular was to develop an extension domain where you could record how much a particular workflow cost you. So, that's the retroactive side, how much did it cost to run this workflow? And it sounds like you already have a lot of that information for your previously run workflows. And maybe if we were able to kind of come up with something where we had the BioCompute object and the cost metrics associated with the particular run, then we could extend that further.
So to add to what Dennis and Hadley you said, I'll give you a very specific example. You have two BioCompute objects, identical, except the seed size is different in the aligner. And we all know that the seed size actually is the most important item in there, other than the input file. Even with the same input file, with the cost can go up, the compute cost. So using BioCompute with the detailed information may actually allow you to think twice before clicking that button. Oh, I want this seed size versus that seed size. Of course, I'm simplifying this for a sequence analysis, and there could be other scenarios. But that's something to kind of think about, where we haven't really done anything at our end other than we spent 6 months playing around with it. But we think that there could be something as Hadley said, coming from both angles. What has been done, and then coming up with some mechanism to even predict what will happen if you do this.
Yeah, I'll comment on the DNAnexus side. I'm very envious of Dennis's 7 Bridges prediction tool. That's very cool. I would love to dig into that some more and see similar results applied to DNAnexus. On our side, there definitely is the challenge of predicting costs. We can do linear predictions where you can know based upon the instances and approximate data going in about how much it'll cost. But as Raja pointed out, there can be a lot of variability. And often, I mean, what I found is it's best to, you submit one and you say, okay, this gives me a data point, I can use this to calibrate. One of the challenges also that comes up for me when predicting data is on DNAnexus, we also do smart reuse, where if you're running a workflow multiple times, if the workflow has identical inputs and identical app steps, we actually can offer the option of reusing the previous execution to get the intermediate outputs that then flow into the new steps of the workflow. So this can offer up some advantages in some cases, because it means that when you run a workflow for the first time, it may cost more than when you run it for subsequent times, especially if there's repeated steps that occur in all of the different executions. If you're always going to be, processing some intermediate files, which are standard references, and so those are always going to go through the same steps, and the smart reuse would basically just take the outputs and would nullify that cost. But it does make it more difficult to predict in terms of figuring out, when you're putting down a total price point for an entire experimental analysis project, how much you're going to need. So this is definitely an area I would love to hear thoughts from the group as you dive into this, in order to figure out the best way that you've found to handle a more generalized cost prediction model. Even if it's not going to be 100% accurate, if it can hit in the ballpark, then we can plug it in and we can determine how we stack up and help submit our feedback as to whether that shows to be accurate, or if we find that in certain cases or certain types of experiments, there may be additional savings. And it looks like Nicholas, they've got tons of statistics already. That's awesome. He's thrown that in the chat for everyone, for anyone who's looking for the prediction times and.
Yeah, I posted a link to a paper that was published a couple of years ago, but I don't think that's been followed up. Probably was a PhD student or something from some colleagues. After that, but we're still collecting a huge amount of data for the three main Galaxy servers, so European, American, and Australia one. And just posted a link to the Grafana website for the statistics on the usegalaxy.eu, which collects runtimes and memory and etc. for all the various tools that have been run since we started collecting this information. I'm not sure if we have all the inputs though, so it's mainly not connected to the size of the inputs.
I see.
I will say one of the biggest surprises for me was the variability in cost. Like there was like different times of day, it was the instance, and I would double check like the actual cost versus what was on the website. And to me, that was a real challenge. And I'll say it from a different perspective. I think we have a handle on maybe how to approach it. But I will say that when we speak to NIH institutes, this is like their number one concern from users and researchers. Can you generalize this cost estimate? It was easy for me because I really knew the workflows and I had a limited question. But how you do that in general, I think it can be done, but it's a little more challenging.
Okay, so there's a couple questions here. Before I do that, I will really just quickly say though that I like, Dennis, your comment on exports for specific applications. I think that was kind of a neat idea and a nice way to leverage the inherent structure in a BCO. We could have, kind of specific prescribed exports for, a given application or given usage that it could be outputted to. I think that is a really, really neat idea. Different ways of viewing the data. So the first one, do you have a BCO that can be viewed and executed in all three platforms, like a simple BCO that uses BLAST or some tool that all three can have? And so I guess, Dennis, I guess you sort of addressed this. We were talking about sharing BCOs across all three, and that is something that would be nice for us to kind of work towards, is like a cross-platform example or set of examples, right?
Yeah. So we have two things that might be of interest to this group. We have one page, and you have to bear with me because my team does all the work and I can't find the pages, but I can get them for you. We have one page with examples of executable BCOs with a runner. And it's basically, Jeff did very small example, like convert an FASTQ file or something along that lines, like one step to make sure that it was runnable. And I think he did 2 or 3 examples. It got increasingly difficult as the size of the workflow. It took a little work to get done. So there's definitely work to do. The other thing that we've done is, we can build on the work the GW team has done where there are BCOs available on Git pages. We've exported a bunch of BCOs to Git pages also. What we could do is label some of them simple examples. And then we can start doing interoperability, reproducibility. I think it's beyond what we talk about in the BCO standard, I believe, but I think it's the right next step, right? Like being able to show that we can not only read the BCO, but hey, you want to run these things, come run it on our platform. And I think for simple utilities, why should everyone use the same different utilities, right? Like, granted, like there's no way we're going to be able to get commercially viable neoantigen workflows shared. I wouldn't even try to have that conversation. But this simple neoantigen workflow, I think, is a good starting point. Can we share that for like a semi-complex workflow? So those are the types of things I would do to move toward showing interoperability between all the platforms.
Yeah, I think from the DNAnexus side, it's both a blessing and a curse that we are able to compile and build a various range of different workflow formats, whether you're talking WDL, CWL, or BCO. But then on the DNAnexus platform, they won't natively be immediately present in BCO. With BCO Nexus, you can export them and get them as a BCO object, but it's not going to be, you'll need to use that BCO Nexus editor in order to pull it out that way. I think we do have export as WDL and CWL, so you can get it in common formats. We do also, I don't think we have it. We might actually have a batch of default demo workflows that we maintain. I know we have a public apps library with a lot of common tools. I think it's got like the top 100, 120 most common tools, and that spans across a range of different genomics focused areas. And so those could always be constructed into a workflow on the fly, which could be set up as something that could then be exchanged. But I think the basic idea, if you pull it off of 7bridges as CWL, and then you use DX compiler to build it on DNAnexus as CWL, that's a one-to-one flow. And so I think it's really if the groups select some that they want to say, these are the starting demos that we feel are most useful to the broad community and would be great starting points to build off of for a wide number of researchers. We could load those up and have those be in, a public demo project on DNAnexus as well, just to sort of show our part and then link them with those on our 7bridges colleague platform and Galaxy.
And to bring it back to, because, while I'm not a government employee, the government is paying my salary on this project. And the whole purpose is to ease the burden for regulatory review. So we have, Galaxy, DNAnexus, and 7bridges all using various forms of workflows and tools and all of these things that have, parameters. Everything we've talked about. But by having you guys kind of funnel everything into the BioCompute object and having it in a common resource does ease that burden, because then, then a regulatory reviewer does not need to be an expert on Galaxy, 7bridges, DNAnexus, Hive, like all the other ones that are out there. They just need to understand how to pull the information that they need out of the BCO. And it's in a common repository that, has a standardized format for reporting these features. So I am so excited after sitting through these presentations today, because I've been working on this since I was doing my master's back in 2017, and to see it finally getting to the point where it's becoming usable in these different platforms. And as Omar said, building a BCO from scratch, regardless of how you're doing it, is agonizing. It can be very, very, very difficult. And like having the Galaxy workflow editor, the 7bridges editor, and the BCO Nexus, like it just makes it so much easier. It's just a snap of the finger in comparison. So that's my piece.
Okay. A second question: in a BioComputeDB, when I'm viewing a BCO, do you automatically hyperlink standard items such as PMIDs, ref-seq accessions, bioproject IDs, etc.? This is not directed to any platform in particular, so I guess I'll open it up. I will really quickly say, though, that this is a little bit tangential, but it reminds me of an example usage that came up in the community, I think maybe a year ago, talking about using it in a clinical setting, specifically because of the versioning capabilities in a BCO. So it could be used to sort of flag, for example, when there's an update in dbSNP based on some SNP call that went from variant of unknown significance to now it's clinically relevant kind of a thing, which I thought was a really, really cool example of it. But I guess, I'll leave this up to any of the platforms that implemented it on their own. Is when viewing a BCO, do you automatically hyperlink to any of these things? This might be potentially appropriate for, future add-ons to these tools, I think, right?
Yeah, I'll say we don't right now, but I do think that would be something that'd be really interesting to explore. It's building the recognition of the appropriate links and also making sure there's the appropriate link building schema in order to ensure that for any input you link to it. Where actually I'm dealing with that on another project of mine where there's all these reference databases, and one of them recently changed their schema for generating the links to specific entries. And we've had to go back and rework all of the basically the generation protocol for it. So I do think it would be good, and this would be something where maybe as a group, as we identify which reference databases are both most useful to have link outs to, and then also follow a standard format, those would be the low-hanging fruit that we could scoop up first, and then tackle some where it may use more complex linking schema.
Mm-hmm. Okay. All right, last one is I would like to integrate BCO creation in our pipeline, but it sounds complex. Where should I start? So I think that sort of depends heavily on which platform or kind of setup you're using. So I guess I'll let either group comment. For ourselves, if you're not using a platform, I can point you to our website. We've got tons of documentation there, biocomputeobject.org. There's lots of great documentation there on BCO, what it is, how it's used, some great technical documentation like the standard itself. And then, of course, there's the standalone editor if you're not even using a platform and you want to manually record one. For example, there's also a great docs site there in the top left for lots of documentation. And tutorials, as I mentioned at the very beginning, there was a great tutorial that walked through using research objects and Nextflow workflow. So I think, if you're sort of platform free, thinking about it, that's one place that you could get started, and I'll leave it up to Dennis and Sam to make any other comments that they'd like to.
So I would say start with a document. Like if you have an actual example you want to do, I think, writing out the domains and figuring out what the information you want to include, like just kind of orient yourself to the standard. There's a lot of documentation. I think just starting with a table of domains with field requirements and kind of understanding them is the right place to start. And then filling it in will be quick. Many editors is the next level up, which is, hey, here's an editor that allows you to edit and save and come back to a BCO, I think is the right thing. I don't think that functionality is quite 100% functional on our platform. I think it's integrated in the platform. I don't know if it's on the free one, but I think, I'll pass it over to Sam to talk about their work. But if you're using Whittle, I would say go straight to the DNAnexus version because we don't support that right now.
Yeah, and I'll say there's two sides to it where there is understanding the BCO side, and Dennis was right on in that there's tons of documentation and figuring out what additional info you'll want to provide for that BCO. That's going to be sort of one avenue. Then the other avenue is, where's your workflow at right now? Is it, complete and polished, and what format do you have it in? Do you have it in CWL? Do you have it in Whittle? Or is it just a bash script and it just happens to run individual programs, and that's the state of your workflow at the moment? And all of those are totally fine, but I think depending upon what state it's going to be in, basically you want to get it in one of these common formats. And so if it's easier to make the jump to Whittle or CWL because that's something that you're more familiar with, you definitely, I think, as we've shown today, it's relatively straightforward to take one of those and convert that into BCO or overlay that onto an existing template BCO with really, you can do that conversion CWL to BCO with 7 bridges, and they've got that really polished tool for it. If you just want to, like, if you've got it in WDL and you want to compile that and then put that into a BCO, or if you've got it as individual apps and you want to start putting those together, then maybe DNAnexus would be a better approach because that's more sort of merge and combine. It comes down to the state of yours. And I would say you'd first want to get it into a workflow language, and then you could either do the conversion to BCO, or if you want to go and start putting it into BCO step by step, it doesn't have to be built as a fully polished one to start. As long as you include the proper domains and you capture the inputs and outputs and the connecting steps of the workflow, like that is at the point where then it's going to be experimentally relevant and you can test and run and put it to use. Then when you're ready to publish, you can go back and you can review that extensive documentation and say, okay, now I'm going to go back and fill in those other domains where, it doesn't need to have the contributors listed in order to be able to be run when you're doing analysis on your own machine, but you will need that when you're eventually getting to the point that you want to publish and share this. So you don't have to take on all those steps, which I think can then make getting into BCO a little less scary when you tell yourself you don't have to do everything. You don't have to fill out every field. Start with just focusing on getting your workflow into a standard format. And then from there on, you can use, I think, pretty much any of these tools to handle the conversion and then filling in the remaining fields.
Yeah, really nice point and very well said. Okay, so I guess that's the last question. And so I think that we can wrap up. So let me just quickly say thank you to all of the presenters. I really like seeing the different implementations for conceiving of and visualizing BCOs. And hopefully this makes it easier to generate and work with BCOs and communicate them back and forth. I really think it does. And I think it helps kind of make it very intuitive for interoperability and for working with them. And now that this infrastructure is in place, I'm really looking forward to future developments for things like re-execution. I think there's a lot of cool things that we can do now that the supporting framework is in place for this whole ecosystem. So that's very exciting. So thanks again to all the participants and thanks to everyone who attended.
Thank you.
Bye, everyone.
Yeah, thank you all.
Thank you all. Bye.